Welcome, welcome. Hey, everybody. All right, well, we did just start, everybody, so please be patient. We'll get some people in here in a minute. Oh, we already have a guest. Love having a guest. Let's talk to Mic Drop. Might be a troll, though.
Hello.
Mic Drop, how's it going?
Good, how are you?
I'm doing all right. Mic Drop, what shape do you think the Earth is?
Right now,
Yep.
I believe it's oblate spheroid. But
All right, but then I'm going to let you go, Mic Drop. It does. I am looking for opposition only. Thanks for being here. Morning, everybody. Why did I get that message? That's weird. I just got a notification from TikTok that somebody sent a message. I got a notification from my TikTok Studio app that somebody sent a message in the chat. That was weird. I don't know why that happened. Hi, everybody. Yeah, I'm doing okay. Doing it just okay. Just fine. Yeah, if that happened for every chat, I would, like, for every message, my notifications would explode, and I would be so annoyed. I would be so annoyed. Oh. Let's talk to Icy. Icy, how's it going?
Hi, hello.
Howdy. What shape do you think the Earth is, Icy?
I think it's a disc.
And why do you think that?
Because it goes through space like a big turtle with everything on its back.
Okay. And I believe I've spoken with Rin before. Let me just double check. By the way, TikTok mods, ban those people. People who come up to troll, just ban them. Do you think most flat earth people on TikTok are bots, just engagement farming? The people who actually run the live streams, no, I don't think so. Yeah, I love the smell of people getting banned in the morning too. Such a great smell. He was trolling, yeah. Like, kind of obviously trolling. There's no request button? There absolutely is. People are requesting. We'll get some people in here in a minute. Adam Groupie, how's it going?
How are you?
I'm doing okay. Adam, what shape do you think the Earth is?
I forget what you call it. It's what's it called? When it's a I guess it'd be an oval.
Do you think that
Well,
it's like a dinner plate
indeed.
shaped oval,
Yeah.
or do you think it's like a basketball shaped oval?
No, like a what's it called? Like a dinner plate.
All right. Why do you think it's shaped like a dinner plate?
So, honestly, this was, I guess, how I grew up. What's it called? When I caught a bass and then I hook setted it. Dude, I
Adam,
got.
you're gonna get banned. Oscar, how's it going?
Nigger.
Wow, you have such a good time. Such a good time you have. Maybe we defeated all of the flat earthers. Maybe there are no flat earthers left. Maybe they all can't defend their views. Lizzie, how's it going?
Dude, I got you.
What shape do you think the earth is?
A dinner plate. Oval.
All right. Why do you think that? Wait a minute. Hold on. No, it's the same guy. It's the same guy. Ban him. Why does he have so many accounts? Can't even read that. Grinks. All right, let's talk to Dimitris C. Milionis. Dimitris, how's it going?
Thank you for inviting me.
Dimitris, how's it going?
So is flat Earth true or false? What is fascinating?
What shape do you think the Earth is, Dimitris?
Oh, as far as I'm concerned, it is round.
All right, well, thanks for being here. Talk to not your mom, not your milk. Not
Dude,
your
you
mom,
ever
not your
said
milk.
a
How's it
ban?
going?
You ever hook set a bass?
Ban him. How many accounts does he have?
What's up?
Kingdom, how's it going?
Good. I'm a flat earther.
All right, you think the Earth is flat like a dinner plate?
No, I'm more of the donut.
Doesn't seem flat.
Well, no. So like, it's not a globe, so to speak. It's actually a donut.
Okay. I kind of don't believe you, Kingdom, considering you
Why?
have a picture of the globe on your profile picture.
Because it's art. It's fantasy.
Okay, you got
That's
a
my
defense
whole
of the
reason.
you got a defense of the donut Earth.
Yes. Drop more
All right.
donuts, everybody. Give them more donuts because the Earth is like a donut.
I thought he was doing the toroidal thing, but no, he was just trolling. Mom, you know what to do. Truth Dog.
Hey there.
Truth Dog, how's it going?
I'm pretty good today. Yeah, I'm not real knowledgeable about the Earth and all that, but it makes me wonder if so much of the Earth is covered with oceans, and there'd be ocean on top of the round and on the bottom of the round and different stuff like that. I said, why does it not how does gravity hold all that together?
Yeah, I mean, gravity pulls things towards the middle, right?
Okay, yeah. I mean, water is pretty fluid. It would take that much gravity to do that. It would pull you right down to the ground. Mostly,
Yep.
you'd feel it.
Yeah, it does.
But yeah, it's just something I kind of wondered about a little bit as far as that goes.
So the gravity pulls the water to the ground, to the middle, and it pulls us to the ground, to the middle. So where's the issue?
I mean, the water is level. The oceans are pretty much level. Yeah.
How do you know? Have you measured them?
No. Am I wrong in thinking that?
You are, yeah. I mean, so you can actually measure this. Either you can measure the front-back curvature, which is easier. Basically, it's the easiest way to do this is to have two people or to set up something that you're measuring on the opposite end of one shore, say a mile or two away, and then measuring how high it is from the other side, and you'll see that it's lower. That would give you a curvature, means it's going down in front of you. Or you can go up to, like in an airplane, and get out like a precision, like a high resolution camera, and then take a picture, and you can see the curvature side to side as well.
Okay, so I guess the Earth is so massive that, like, if you see a big water puddle or a river, you know, that's kind of still, it appears level, but it would actually have some type of a curvature, I guess.
Yeah, I mean, it is just a reality that, like, the Earth is really big. So it will be the case that if you're looking at it from really close up, it's going to look pretty flat. But when you get out precision measuring tools, you eventually find out that it's not.
Okay, where did like flat earthers they ever come up with such a thing? I mean, was it in the Bible or something like that? Or?
People point to the Bible, but you'll find that, like, most people who, like, there are people who are biblical literalists. They think that, like, everything that the Bible says is true, and they don't think the Earth is flat. So that's up to interpretation. But really, this idea, this kind of modern idea that the Earth is flat, really originated in the late 1800s with a guy named Samuel Rowbotham. He wrote a book called, is it Zetetic something? Zetetic Astronomy. He wrote a book called Zetetic Astronomy, where he claims that the Earth is flat, and then he gives basically all of the arguments that modern flat earthers give. So their argumentation is around 130, 140 years old, but that's where it comes from. Oh, I'm sorry. It's like 180 years old, rather.
Okay, yeah, I kind of wondering about that. You know, you hear different things about it, and I never really had an opinion about it either way. I'm just here on Earth,
sure,
and never kind of concerned myself the actual shape of it. Like, yeah, but yeah, it threw a couple of questions into my mind. You know, about okay, where did this come from, or could it be true? You know, as far as that goes, I'm not sure. Like in the Bible, God warned not to add to it or take away from it because he knew that people would do that. And
sure,
obviously, how humans are, they're going to add to it to suit their own whatever they think they want to do or whatever. They're going to add something to say, okay, this is what God said when he didn't. And they say it so that they can justify their own what benefits them, you know, I'm sure, because, you know, he wouldn't have warned, don't add to it or take away from it if he wouldn't have known that, you know, he knew that people would do that. So,
yeah,
you know,
I mean, like, look, I'm not a biblical believer. I'm not like a big Bible guy, but I just think that, like, we don't need to rely on a book that was written a very, very long time ago to figure out what shape the Earth is, right? We can just go out and measure this.
Yeah, that's, I'm sure, you know, they have, in this day and age, they have scientific evidence, measurements that they can do. And as far as other planets, they observe other planets that are round.
We can just look at them with a telescope, right? And they're round.
Right. They're round, so why wouldn't, you know, stand the reason? And another thing I wondered is there's two planets that rotate in opposite rotation from the other planets. I'm trying to figure out how that happens when they all rotate in the same direction, except for two of them.
So it's really only one that rotates in the opposite direction. It's Venus. And Neptune, whereas you know, Earth rotates this way, Venus rotates this way, Neptune rotates this way. So Neptune is tilted on its side, but it's not in the opposite direction, perhaps. But look, these are really, really excellent questions, but they're not for this live stream. So I'm going to let you go, Truth Dog, but thanks for being here.
Sure.
All right, let's bring up Chopper.
Hello?
Chopper, how's it going?
Yeah, I guess I suppose I wanted to ask you a question. I don't know if that's possible.
Sure, but before you do, what shape do you think the Earth is?
Oh, dude, I don't know.
Okay, yeah, sure, go ahead. Ask your question.
Yeah, so this is a real question, and I honestly mean it. Have you ever caught a bass?
Yeah, I figured it was the hookset bass guy. By the way, mods, don't do 24-hour blocks. Do permanent bans. Right, permabans. Just so you know. It's like the same guy. Where does he get all of these accounts? Watch it be the same guy.
Dude, I just want to answer, dude.
Well, you're gonna get a permaban. How does he have so many accounts? Why does he have so many? What is his, like... Eventually he's gonna run out of accounts, and what that means is that he's just not gonna be able to watch my live streams anymore. And the fact that he's coming up to ask these questions means, at least it seems like it means, that he finds it fun to watch them, or at least fun to be here. Watch it be the same guy.
Dude, just yes or no.
The same guy. Why does he have so many accounts? He is such a fan. That's really funny. Oh no, you can't watch if you're banned. If you're, or sorry, not banned, if you're blocked. If you don't give him like 30 seconds, I can't ban him. Okay, good point. Okay. Sorry about that. Talk to Trent. Trent, how's it going?
Hello? Can you hear me?
I can hear you just fine, yeah.
Okay, I'm not the bass guy. I just have a question.
If you ask the bass question, you're gonna get banned.
No. I actually have a question.
All right. Well, before you start, what shape do you think the Earth is?
I'm 50-50 on it.
Okay, go ahead.
What is your defining proof that the Earth is not flat?
I mean, it really depends on the person, right? Like, some people will find some things more convincing than others. But if I had to give one that's probably most convincing to most people, I would just bring up the... Sorry, there's some background noise and it's making me hear myself.
Sorry,
Are you on Bluetooth?
I'm outside.
Are you on speakerphone? Of course you're on speakerphone.
I don't think so.
Sorry, do you have headphones in?
No, I don't. I'll mute myself when I'm not talking, though.
Okay, sorry. Yeah, it's one of those things that, like, it's like a voice jammer. Anyway, so one of the things that I like to bring up is what we see with the clouds during sunsets and sunrises. And I can just show you a picture really quick. So where is this picture? So here's a picture from, this is from an airplane. Let me pull it up. And this isn't the most sophisticated proof, but it's definitely pretty intuitive. So here's a picture from an airplane around sunset, right? And you can see that, like, the bottom of the clouds are reddish and the top of the clouds are gray. And then we can look at the same thing, or a similar picture from the ground. And you can see that, again, the bottom of the clouds are reddish, orangish, and the top of the clouds are gray. So what's going on here is that somehow the bottom of the clouds are being illuminated, and they're blocking the top of the clouds from being illuminated. If, you know, it means that the light's coming at it from the bottom and not getting through to the top. And so what that means to me is that if the Earth was flat, then somehow the sun would have to be lower than the clouds, right? Because it's the bottom of the clouds that are getting the light and not the top of the clouds. But if the sun were lower than the clouds at sunset and sunrise, then two things would have to be true. One, an airplane would be able to fly into the clouds because airplanes can fly higher, or an airplane would be able to fly into the sun because airplanes can fly higher than clouds. The second thing is that somehow, when it's sunset or sunrise for one person, a quarter of the way around the globe, it's going to be noon for somebody else. And when it's noon for that other person, the sun is above the clouds. You know, the clouds can block out the sun, which means that the sun is above the clouds. So somehow the sun is supposed to be below the clouds and above the clouds at the same time. It doesn't make sense if the Earth is flat. If the Earth is not flat, it makes perfect sense, because then what's happening is that the Earth is rotating away from the sun, and the sun rays are getting through to the bottom of the clouds because the Earth is rotating, and so the clouds are rotating with it. I think that that's probably the most intuitive piece of evidence that we can provide. I don't think that there's really any better explanation for how you can get this sort of bottom of the clouds being illuminated if the Earth was flat.
I understand where you're coming from with that. I like to discuss these things in ways that make it seem like, oh, I'm not biased, or I feel one. I like to learn why people feel the way that they do, and I like to discuss these things. For me, what made me not understand, but what made me feel like, oh, something isn't right here, was that I would go down to my uncle's down in Florida. I'm from like the northeast of the US, and it doesn't matter what time of the year it is. And this isn't very like strong proof or anything like that, but this is something for me that made me feel like, oh, the sun is closer than they make it seem. Whenever I go down to Florida from up in the north, it just feels like the sun is a hell of a lot closer. Like it feels like it's radiating you a lot more. And I know there's probably scientific explanations and stuff like that, but for me, that and the stars being the same every night have always made me think like, like what's really going on here? I'm not saying for one thing or the other. I'm just a very skeptical person.
So why do you think that the stars are the same every night?
Well, if we were drifting around a ball and our ball was also turning, I feel like we should see different sets of stars. No?
We do. Yeah, there are stars that you can only see in the summer, and there are stars that you can only see in the winter.
But wouldn't there be different constellations though?
There are constellations we can only see in the summer and constellations we can only see in the winter.
Yeah, see, like I said, I'm not like, you know what I mean? I'm not going to come here and say like I'm some sort of, smart expert. I'm just giving my opinion on what I feel. You know what I mean?
So in fact, Trent, what's your star sign?
Aquarius.
Okay. So you know that the star signs are constellations, right?
Yes.
Okay. So have you ever looked out into the sky and seen the Aquarius constellation?
Not specifically, no.
So next time it's your birthday, go out at night, or around your birthday, go out at night and see if you can find the Aquarius constellation.
I just want to point out, I got a lot of people in the chat calling me out. I'm not here to say that your point is wrong or that my point is right.
You're fine. Don't worry about the chat. Don't worry about the chat.
I just want to discuss my thoughts. You know what I mean? Like everybody's got their own opinions.
It's fine. Don't worry about the chat. So what you'll find is that if you go out around your birthday and you look for the Aquarius constellation, you won't be able to see it. And the reason you can't see it is because the way that we define what your star sign is it is the constellation that is blocked by the sun during that month. So what you will find is 6 months after your birthday, you will be able to see Aquarius, but not on your birthday. And that's just because the Earth is going around the sun. And so the night side is pointing in different directions at different time of year.
Gotcha. Well, I appreciate you being like cordial about this discussion. Your chat seems to be a little bit of pea brains that don't know how to have a simple discussion, but I like you, bro. I like you. And I hope you have a good day. All right.
I appreciate that, Trent. Have a good one. All right, let's talk to Mr. Fancy. Mr. Fancy, how's it going?
Yo.
Mr. Fancy, how old are you?
15.
Can't be here. Sorry, bud. I really hope there are no 15-year-old flat earthers. That would be very disappointing. All right, let's talk to YSG. Seems like all the flat earthers have disappeared.
Hey, what's up?
YSG, how's it going?
Doing good.
Glad to hear it. What shape do you think the Earth is?
I think it's spherical, but
So why'd you join?
I do have a question. Well, why isn't there like high footage or high quality footage? You know,
There
like
is.
like a 12-hour stream. I mean,
There's
it's
24-hour
like
live streams from the International Space Station.
true. I guess I haven't looked into it. I mean, that was the only question I had. So,
All right, get out of here. I feel like I've spoken with Kravis Roberts before, but I don't remember. Kravis, how's it going?
I'm a pussy-loving man.
Oh yeah, it's this guy. All right, let's talk to Gladiator Hub. I think we've spoken with him too, but it was a while ago.
Hey, what's
Gladiator
up,
Hub, how's it going?
Good, how are you?
Doing okay. Gladiator, we spoke a while ago, right?
Yeah, we did.
Like 2 or 3 weeks ago or something like this.
That other debate guy joined. I forget his name.
Oh, that's right. Yeah, this was the conversation with Dean. That was funny. Have you looked into more of the flat Earth stuff?
Oh, I've been looking into flat Earth since like 2021.
Okay, so were you here when I was explaining the clouds and the sunsets?
Oh, what, today? No, I just saw you live now. Like
No,
a minute
that's
ago.
fine. That's fine. I just wasn't sure if you had heard the explanation. So instead of talking about Artemis, why don't we talk about things that we can do ourselves? So, surely you've seen a sunset before, right? I imagine you must have. So, you know, and if it's cloudy out during a sunset, it looks something like this, right? That's what the sky looks like. Right?
Yeah.
And have you ever been on an airplane during a sunset?
Yeah.
If it's if it's cloudy, it looks something like this, right? You know, maybe like these clouds are really nice, but like, you know, you can see that they're red on the bottom and that they're gray on the top, right?
Yeah. So it's like it's being illuminated from the bottom.
Right. And so my question is, if the Earth is flat, it seems like the only way to illuminate the clouds from the bottom during a sunset is if the sun is actually lower than the clouds. Right?
Well, that's not really how light works, because light can bounce off a lot of things.
Sure, but if the sun was higher than the clouds, then you would think that the top of the clouds would be brighter than the bottom of the clouds, because when light bounces off of something, it gets dimmer, right?
No, I mean, I see what you mean, but to me, it's like I've seen things not be directly in sunlight, but they still get lit up, you know?
Yeah, that's reflected light, which is dimmer. We would say that those are things that are in shadow, right? Like you can still see when you're standing underneath a tree, when you're in the shadow of the tree, but it's dimmer than if you were standing out in direct sunlight, right?
Right.
So it seems like if the top of the clouds are darker than the bottom of the clouds, then whatever sunlight is getting to the top of the clouds, that has to be the indirect sunlight, and the bottom of the clouds has to be the direct sunlight.
The problem is, though, is as the sun gets further away, and I mean, this is like the general model that most flat earthers believe, is as the sun gets further away, it converges into the horizon, right? So compared to where those clouds are, where you are, the sun will appear and the light will appear to be coming from a place lower than you and the clouds.
How would it being far away make it so that the light that hits it directly is from the bottom rather than from the top?
Because you got to think how we see the sun is it's not like we're seeing the actual placement of the sun. It's just our personal perspective.
I'm not worried about how we see the sun. I'm just worried about the path that the light takes.
No, but that's what I'm saying. Like we see the light take a certain path depending on where we are. It would change depending on where you are, obviously.
So where do you think the sun is when the bottom of the clouds are illuminated and the top of the clouds are dark?
I don't know. I mean, I haven't personally seen something like that, but
I just showed you two pictures.
I'm guessing in that picture, it would be very far away. I'm guessing
I mean in altitude. What is its altitude at that time? How high is it above the ground?
I don't have any claims to know how high the sun is.
Okay,
or where it is.
I'm not asking for an exact number. I'm asking, do you think it's higher than the cloud or lower than the cloud?
No, I think it's always higher than the clouds, obviously. But I think it's what you have to understand. Like, okay, so you see on this picture where you're taking that picture.
Yep. Yeah, this is from an airplane.
The sun is further away.
Right,
than
further away, but it's still higher than the clouds, right?
No, it's not, because you can't see the sun there.
No, I'm talking about I'm talking about the actual altitude of the clouds, or the actual altitude of the sun. Not like where it appears to be, whatever. Like, you can shout perspective all you want. I'm asking, how high is the sun literally above the ground? Is it higher than the clouds or lower than the clouds?
It's higher than the clouds.
Okay, so then how is it that the top of the clouds are dark? The sunlight, like imagine a light bulb, right? Doesn't matter how far away the light bulb is. If it's higher than a table, the top of the table will be lit and the bottom of the table will be in shadow. If it's lower than the table, it doesn't matter how far away it is. The bottom of the table will be lit and the top of the table will be in shadow.
No, but if the table's big enough and the light's far enough away.
How do you figure?
I mean, that's just how perspective works. Everything converges into the horizon.
We're not talking about perspective. We're talking about whether or not a thing is illuminated. This has nothing to do with like human eyes or anything.
No, but it is. It's exactly to do with human eyes. That's how we perceive
it's not.
things. That's how we perceive it being illuminated. It's just our personal perspective.
Whether wherever the sun appears to be is irrelevant for the fact that the bottom of the clouds are illuminated, right? Like, it's just a fact that the bottom of the clouds are illuminated, yeah?
Okay, but where's that light coming from then?
That's the question.
Wait,
That's
it's
what I'm
coming from
asking
the sun, right? I'm sure we can both agree it's should be coming from the sun. So if it's on a globe, then how is it coming? If it's already set, the sun's already set in this image. So where's that light coming from?
I could draw you a diagram. I'm working on a diagram right now for the flat Earth, though, really quick. Let me just show you something, okay? Let me pull up switch this over to paint. That way then we can draw together. Okay, so I'm going to draw a cloud over here. And this is not going to be to scale, but I'm gonna draw a cloud over here. Right, and I'm gonna put the sun higher than it, far away. Right, so that's higher than the clouds. It's also far away. Now, I agree that, you know, the sun shoots out light in all directions, right?
Yeah. Well, I mean, wait, is this supposed to be on a flat Earth?
Yeah, this is supposed to be on a flat Earth. Sun shoots out light in all directions. So let's fill in the light that's being shot out in this direction, just so then we can see in more detail what's going on near the cloud. Oops. Right. So what's happening is that, if you zoom in on the cloud, that the top bit of the cloud is illuminated. The top bit and the bit that's closest to the sun is illuminated, but none of the bottom bit is illuminated. Oops, sorry, you can't see that. None of the bottom bit is illuminated. Like, you could argue that maybe like this part is illuminated, like the back bottom bit is illuminated, but it won't be the whole bottom of the cloud.
That's not really how light works. Like, it doesn't just go in straight lines like that.
Oh, it doesn't?
No, like the bottom.
What way does light go in?
So you're acting like all of the bottom just would never get illuminated.
Well, I mean, it might be illuminated by some reflections, surely. We would have some reflections here, and then those reflections would be dimmer, so I'll draw them as thinner lines. So we would have like a reflection there, and maybe we have like a reflection here, but that would be like significantly less light than what's getting through to the top of the cloud, right?
Yeah, but whereas
the ground isn't a mirror.
Your sun on that image is still higher than the clouds, and it's still near the clouds.
But you said that the sun is higher than the cloud.
No, but I said due to our perspective, it's gone so far away that
I'm not asking about perspective. I'm just asking about how high is it actually above the ground.
That's the answer to your question.
My answer is how high is it actually above the ground? It's not a question about perspective. It's not a question about how it appears to be. I'm asking how high is it actually?
Like a specific number on how high it is?
A relative number is fine. We've been over this. I don't care the exact number. I just want to know if it's higher than the clouds or lower than the clouds. The clouds are 3 to 5 miles up on average. Is it more than that or less than that?
No, it's more than that. But when the sun's got so far away that it's setting, it looks like, from our perspective, it is converged with the horizon. And
I don't care about perspective. It's irrelevant. Perspective is irrelevant for this question. Light travels in a direction.
It's not. That's exactly what it is. We're talking about seeing something.
This isn't perspective. Whether or not the top of a cloud is illuminated or not is not perspective.
No. It's about where you are seeing it.
Regardless of where you are, if you're looking at the same cloud as somebody else, the cloud will either be illuminated or not, regardless of where you are relative to the cloud.
No, I'm saying the perspective between you and where the sun is, not where you and the cloud is.
Look, so where the sun is the thing in question. I'm not asking about where it appears to be, which is what perspective is. I'm asking about where it actually is. Right? How high is it above the ground? Is it higher than the clouds or lower than the clouds? And it seems
the sun is always higher
it seems
than
like
the
you're
clouds.
incapable. Okay, so if the sun is higher than the clouds, then the light beams should always illuminate the top of the clouds more than the bottom of the clouds.
Not if it gets far enough away.
How would getting further away make it? Okay, suppose that I stretch this out way more. Suppose that I stretch this out all the way over here, and then I take the sun and I move it all the way to the right side of the screen. How would that make it so that the top of the clouds is any less illuminated?
Okay, have you ever seen like railway tracks?
Can you answer my question, please?
Yeah, but this is to help you visualize it.
Okay, sure.
Right. So how do you think we see
we can actually just
a Euclidean way or non-Euclidean?
I don't think that you could define what Euclidean is, so it's probably not a conversation worth having.
Okay, well then we'll keep it simple. How do train lines converge? Do they are they when
the
train lines
angular
are parallel,
the
right?
angular distance between them?
Do they stay parallel in our vision, or do they appear to converge?
The angular distance between them gets smaller because
Right.
the way that we measure, or the way that you define angular distance, is essentially size divided by distance. So if the distance gets bigger and the size stays the same size, then the angular distance will get smaller.
Right, so in reality, the parallel lines never touch, but due to our perspective, it looks like they converge. The further
but this isn't. We're not asking.
So
I'm not asking a
happens with
question
the
about
sun.
perspective here. No, but I'm not talking about perspective here. That's what you're missing.
But I'm saying that the same thing happens with the sun,
This
and that's how we view it.
So, do you think that the light from the train tracks is bending, which is why they appear to converge?
Not the light from the train tracks. No.
Okay, so then so then why does this have anything to do with the sun?
Because the sun's a physical object as well.
Okay, so there's our cloud. We're going to put the sun way over here.
I don't think it's something you can really visualize with a 2D software. But
literally, you can. Of course you can. You can just imagine looking at it from the side. I don't know what the contention is. So here we have our light rays. Oops.
But do we agree that when the sun sets, what it's doing, it looks like it's going like below a horizon, right? So it is getting lower in the sky.
That's exactly
it looks
what
like
it looks
getting
like.
lower in the sky, right?
Yep, it definitely looks that way. But the question is it actually getting lower in the sky?
No.
Okay, so then how is it that the bottom of the clouds are illuminated? By the way,
because the light looks like it's coming from lower in the sky.
It sounds like you're just proving my point right, which is namely that the reason why it appears lower in the sky is not because it's not because the Earth is flat and it's getting further away, but because the Earth is actually turning away from it. But look,
that's the thing. There's two different explanations. So
I just put the sun.
This doesn't really like work.
I just put the sun. I just put the sun far away. Like I just quadrupled the distance, right? And
but you need
what
to
we
put the sun
find
down towards the horizon. It's still above the horizon.
No, but the sun is actually high. It's actually above the clouds.
We're talking.
We're not talking about where it appears to be. I don't know what you're not understanding. We're not talking about where the sun appears to be. We're talking about where it actually is.
Okay, I know. But the picture that you showed, right, was obviously of a sunset. So the sun had set, right? So for you to now show an image of the sun not setting is disingenuous. Well, and that's why it's not an accurate representation.
At sunset,
so
how high
if you move that sun lower down to the horizon.
At sunset, how high is the sun above the ground? Is it higher than the clouds or lower than the clouds?
Physically, where the sun actually is in reality,
where is it actually? Okay, so then drawing it where it is will not lead us astray.
Perspective.
I can assure you I can understand perspective far better than you do.
You're not grasping what I'm saying.
Perspective's irrelevant for this question because perspective is about how we perceive things. It's not about whether or not a thing is illuminated. No,
okay, so
unfortunately,
this is what
it's not.
We differ on is that the way we perceive the things in the sky is not the same way that we perceive something down here far away like a building.
Do you think that whether or not
in the same way?
Do you think that whether or not a cloud is illuminated is due to perception or due to perspective?
Absolutely.
Okay, so you think that like if you move further away from the cloud or if you move closer to the cloud, it'll change whether the bottom of the cloud is illuminated or not?
If you move closer to the sun,
well, no, perspective is about where the observer is for the thing that they're looking at, right? Perspective isn't about the relative position of two objects and then you're in a fixed place. Perspective is about where you are relative to the thing that you're observing. And so we're observing a cloud, right? So do you think that if I'm over, just gonna draw a little person. Do you think that if I'm over here, the bottom of the cloud will be any less illuminated than if I were, say, over here?
No, because you're basically in the same spot. So
no, definitely not in the same spot. Obviously not to scale, but this is a very large distance. This is like, dozens or hundreds of miles. Clouds are big, it turns out.
But if someone's dozens or hundreds of miles away, how would they see the same cloud? So it's just not really.
Clouds are big. You can often see the same cloud for dozens or hundreds of miles.
The exact same illuminated cloud.
The same cloud, yeah. You can often see the same cloud.
Clouds, yeah. But
no, you don't understand that you can see the same cloud from like dozens or hundreds of miles away. How big do you know how big clouds are?
Yeah, they're pretty big, man.
Yeah. So like you could definitely see the same cloud. If it's a big cloud, if it's a little tiny baby cloud, then like, yeah, sure you can't. But if it's like a big cloud, you could definitely see the same cloud from dozens to hundreds of miles away. Of course, it'd have to be really big to see it from hundreds of miles away, but from dozens of miles away, certainly. And so this cloud, say these two people are separated by 20 miles, right? Would they see the cloud being illuminated the same way, even though they're from different places? They're looking at it from different perspectives.
They'll both see illumination on their clouds. My problem is still in this diagram is the sun is still not below the horizon.
Well, that's because the sun's not actually below the horizon. I'm just drawing it where the sun actually is.
Due to our perspective. What does it look like when the sun sets?
You realize that our perspective is not a representation of like reality? You understand that?
Agreed.
Okay, so that's why I'm drawing it where it actually is, rather than where you think it is, or where it appears to be.
But that's relevant to this.
It's not relevant because we're looking at the clouds, we're not looking at the sun.
Because we're talking about how we perceive reality, not about where it actually is.
Well, we're looking at the clouds, and whether the cloud is illuminated or not is not a subjective question, right? The cloud is either illuminated or it's not.
Yeah,
this does not come down to
something
perspective.
Gets further away,
this does not come down to subjective opinion. This is objective. The cloud is either illuminated or it's not.
Yeah, I know. I'm not denying they're not illuminated. I'm not denying the phenomenon.
So the cloud is illuminated.
I'm just explaining to you how it works.
Okay, so how is it that the sun can be actually above the ground, and somehow it's illuminating the bottom of the cloud? How does that work?
No, it's the light is illuminating it, not the actual sun.
Yeah,
the light can travel.
Where does the light come from?
The sun, the actual
where does the light come from?
So far away.
Where does the light come from?
A sun set, right, goes down.
Yeah, okay. So where does the light come from?
It comes from the sun.
Okay, so the light comes from, it starts here. So the light starts here. And then what's the path that it takes to get to the bottom of the cloud?
You still haven't got the sun where it should actually be. It should be below the horizon.
I'm drawing the cloud where it actually is. Not where it appears to be. I'm drawing it where it actually is. So how does the light get from the sun, from where the sun actually is, to the bottom of the cloud? If the sun originates, if the light originates at the sun, you agree that the light originates from the sun, right?
Yeah.
Okay, that means that the light has to go from where the sun actually is to where the cloud actually is. So how does it get from point A to point B?
Well, I'm not disputing that.
Can you answer my question? How does the light get from point A, which is where the sun actually is, to point B, the cloud? What's the path that it takes? Okay, what path does it take?
The speed of light.
What's the path that it takes? How does it get to the bottom of the cloud?
From point A to point B.
Okay, so is there a line connecting the bottom of the cloud to the sun? No, it would have to pass through the cloud to do that. So what's the route that it takes? Does it, I don't know, does it do this? And then it just like sweeps down and then goes back up?
No.
Like, so then what's the path that it takes?
Light spreads out uniformly.
Yeah, like in the drawing that I've done, right?
Right. So light's coming from everywhere.
Why can't I erase? Oh, there we go. So wait a minute, hold on. Light comes from the sun, not from everywhere.
No,
right?
I mean when it comes out of the sun, it's not like it comes out in one like straight line. Is what I'm saying. It comes out like everywhere almost.
Oh yeah,
it's like an explosion of light. To say it crudely.
Yeah, I mean like it comes from like here and it comes from like there and
exactly.
Oh, but so
now if you've got the sun, if you put that sun lower, and you do those same lines. I know that's why you're not putting the sun lower, because
I'm not putting the sun lower because you think that the sun. I'm not putting the sun lower because you think that the sun is higher than the clouds. I'm just putting the sun where you think it is.
From where we see it, it looks like it's from lower, so it looks like the light is coming from lower.
I don't care what it looks like.
This man. Also, this doesn't disprove a globe Earth. It doesn't disprove a flat Earth.
It does. It does actually. It does not work on a flat Earth.
It does. I've just explained how
does it work? How does the light go from
sun far away and lower?
It is far. Wait, why would I move it lower?
Is coming
why would I move it lower?
Because that's where we see it. That's what a sunset is.
Wait, but where is the sun actually?
In the sky.
Where is the sun actually?
Does the sun get lower or higher in the sky when it's set?
Where is the sun actually? I'm trying to draw an actual physical. Well, so in my view, the sun's not moving. The Earth is rotating, right? But in your view,
what does it appear to happen?
Sure, it appears to get lower in the sky, absolutely.
Right.
But that's not like a true depiction of what the sun is actually doing. That's just how things appear. So the question is I'm trying to draw the physical scenario as the world actually is. And if the world is actually flat, during a sunset, the sun is actually still above the clouds, right?
But it's so far away that
distance doesn't save you here.
It really does, because that's how perspective works.
How does distance make it so that the sun can curve around and get to the bottom of the cloud? What's going on there?
The sun is curving around.
I'm talking about the light, not the sun. How is the sun getting to the bottom of the cloud?
Because the sun has gone so far away, it appears to go lower.
Okay, that's not answering my question. How is it?
It is.
Look, the sun is actually higher than the clouds, right? In your view?
Yeah, but in your model, the sun is actually higher than the clouds.
No, in my model, it's not even a good. It's not height above the Earth is not even a good model. Is not even a good way of talking about where the sun is, because the height above the Earth is in different directions at different places. So it's not even really
But it is.
If the Earth is a basketball, going up in one direction is going away from the sun, whereas going up in the other direction is towards the sun. So there's not some unique distance that you have to go up in order to get to the sun, right? On a globe, question of height above the ground is not really a great question. You can talk about angles, and that's the best thing that you can do.
But it objectively is for everyone on the globe, from their perspective, it looks at one point in the day
you can't
the sun
say,
is higher
okay,
than them, and then
Gladiator,
it's lower.
I don't know what you're missing about this, but you can't say it objectively is and then say from their perspective, because if you're invoking the perspective of somebody, that makes it subjective, not objective.
No, but perspective, like what you see is I'm not saying it's objectively real, but that's
okay. So I'm trying to draw a diagram. I'm trying to draw a diagram about where the sun, invoking the actual physical conditions of what's actually happening, not about what our perspective is. Okay, so you think that the sun is lower than the clouds?
If you just move that sun down, it would make sense.
Right. No. So you think that the sun is lower than the clouds? Why can't planes fly into it?
That's not what I'm saying.
Well, okay, so I'm trying to figure out where the sun actually is, not where it appears to be. I don't know why.
I don't claim to
that's
know
hard to grasp.
how high up or far away the sun is. I don't claim to know what medium it exists in.
You don't have to know those things. That's why this is a reductio, by the way. So what's happening is that if the sun is higher than the clouds, then you can't account for the fact that the bottom of the clouds are illuminated. If the sun is lower than the clouds, then you can't account for the fact that planes don't fly into the sun. In both cases, you can't account for the facts of the world as we observe them, which shows that one of the initial assumptions, namely that the Earth is flat, is false.
Okay, but then I could just turn around and say, oh, well, then why do planes assume that the Earth is flat and stationary when they fly, and they don't fly into the curve of the Earth over? Well, they do.
No, they don't. Can you show me evidence of that? By the way, as long as it sounds like you've conceded on this point, so we can move on.
No, I want to stick to that point, but I'm just using that logic against you to show that is bad.
So you're talking about a 1986 flight manual?
I'm talking about any pilot ever will tell you that they don't have to assume curvature or assume the spin of the Earth when they fly.
Wait a minute, that's a different claim than what you just said. You just moved the goalposts. Sorry, that's a Martin Bailey, not a...
I said that planes and flying does not assume for a curved spin.
Yeah, and then you changed it to pilots. Pilots and planes are different things.
Same thing. Pilots or planes.
Wait, sorry, a pilot and a plane are the same thing?
I meant flying. Yeah, it is the same thing. Of course.
A pilot and a plane are obviously not the same thing. No, I'm not being semantical. I'm catching you out on a Martin Bailey fallacy. So planes do account for the curvature. In particular, they account for the curvature in their gyroscopes, which are used to maintain orientation. They absolutely do. And you can go look up pendulous vanes. Pendulous vanes were analog ways of adjusting the analog or the mechanical gyroscopes back in the day before we had digital gyroscopes and GPS and the like. Now, pilots don't have to adjust those manually because the machinery is built so that it's automatically adjusted for the attitude indicator. So the artificial horizon stays where it's supposed to be even as they're going around the curvature of the Earth. The pilots don't have to account for that. The gyroscopes do.
It stays flat.
Why do gyroscopes have pendulous vanes?
What's the gyroscope assuming?
Well, gyroscopes aren't people, so they don't assume anything, but they correct for the curvature.
How does it correct for the curvature? You're just saying it.
So back in the old day, they used something called pendulous vanes, which were essentially little air inlets that would open as the gyroscope changes its orientation. With as you fly around the curvature of the Earth, the gyroscope stays in the same orientation. So as you fly around the curvature, the gyroscope will appear to be in a different orientation relative to the gravitational pull. And so that would mean that the gyroscope is in a different orientation compared to local vertical. And so there are these little slots that would open on the gyroscopic container that depend on the angle that the gravitational pull is in. And so that would open up and let air flow in to adjust the gyroscope so that the gyroscope is now in line with the gravitational pull again.
Why doesn't that work on a flat Earth?
Because, well, they're not necessary on a flat Earth. The pendulous vanes don't do anything on a flat Earth because the gravitational force vector is always in the same direction on a flat Earth. Well, there's actually no gravity on a flat Earth to begin with, so none of this makes sense. But you know, if we're being maximally generous, then
you're assuming it wouldn't work on a flat Earth because there's no gravity.
Well, no, a pendulous vane isn't necessary on a flat Earth. So why would they include it in the gyroscope?
Because they assume that the Earth is curved.
You're right. So we agree. You just proved
but it's
to
not
me.
necessary.
Hold on. I just want to play you back something.
It would still work on a flat Earth.
Hold on. I just
want
to
still worked before.
Gladiator, shut up for a second. I just got to play something. One sec. I'm gonna mute you, but not because you're being rude. Just so then we can listen to the thing. Okay?
No worries.
Indicator. So the artificial horizon stays where it's supposed to be.
Flying does not assume.
Sorry, that's a Martin Bailey, not a.
I said that planes and flying does not assume for. Curved.
Yeah, and then you changed it to force vector, and so that would. And now let's play the other thing. You just proved
but it's
to
not
me.
Necessary.
Hold on. I just want to play you. Why would they include it in the gyroscope?
Because they assume that the Earth is curved.
So which one is it? Do they assume that the Earth is curved? Do they not assume that the Earth is curved?
They do assume the Earth is curved.
Then why'd you say that they don't assume that the Earth is curved?
I'm confused. I don't.
I'll play it back for you again.
Yeah, play it back. Just saying it.
So back in the old day,
it's flat.
Curvature of the attitude indicator. So the artificial horizon stays where it's supposed to be, even as they're going around the curvature of the Earth. The pilots don't have to account for that. The gyroscope. Sorry, pendulous vane or countable. Wait, and then you changed it to pilots.
Or the
6 flight manual.
So
it sounds like you've conceded on this point, so we can move on.
No, I want to stick to that point, but I'm just using that logic against you to show that is bad.
So you're talking about a 1986 flight manual.
I'm talking about any pilot ever will tell you that they don't have to assume.
Oh, sorry, we have to go back a little bit further. One of the initial assumptions, namely that.
Oh, well, then why do planes assume that the Earth is flat and stationary when they fly, and they don't just turn around and say, oh, well, then why do planes assume that the Earth is flat and stationary when they fly, and they don't.
So, sorry, which one do they assume? Do they assume that do the planes assume that the Earth is flat and stationary, or do they assume that the Earth is curved?
They assume it's flat and stationary, but I'm saying that pilots think that it's curved. Or people who engineer it.
Hold on, just
I'm confused. They still assume it's flat and stationary.
One sec.
Because they assume that the Earth is curved.
You're right. They include it in the gyroscope. Necessary on a flat Earth. So why would they include it in the gyroscope?
Because they assume. I've still got the same take. They assume.
You're right. The planes assume it, or perhaps the plane designers assume it.
Yeah, not the actual plane. The planes
don't do anything.
Yeah.
Right.
Yeah,
so on the one hand, you're saying that the planes. On the one hand, you're saying that the planes, which we're really talking about the plane designers, assume that the Earth is flat and stationary. On the other hand, you're saying that the planes, again, the plane designers, assume that the Earth is curved. It sounds like you can't have both.
They think the Earth is curved.
Well, that's not what you said. You said that they assume it's curved.
They assume it's flat and stationary because it doesn't matter to add rotation or curvature.
Wait, so why would they assume it's flat and stationary and then also include the pendulous vanes in an old-timey plane?
Why didn't the Wright brothers have to include that when they flew?
They didn't have a gyroscope at all.
Yeah, but they flew and they didn't crash
for like
into
20
the curvature
seconds.
of the Earth,
You need a gyroscope.
Many people flew after that, right?
Gladiator, you need a gyroscope so that you can navigate properly. The Wright brothers weren't trying to navigate.
Yeah, but that's just navigating northeast, southwest. It's not an altitude. It's not anything to do with the curvature of the Earth.
What the gyroscope is there to do is to tell you what direction you're going in.
Right. So that can work on a flat Earth as well.
A gyroscope would work on a flat Earth, no problem. The trouble is that a gyroscope wouldn't need a pendulous vane or pendulous vanes if the Earth was flat. And yet,
what does the pendulous vane show us?
I've already explained this to you. The pendulous vanes realign the gyroscope as the gyroscope tilts relative to the surface of the Earth. So as you're flying along, the gyroscope tends to tilt backwards, basically, and the pendulous vanes readjust it so that it's tilted forwards, so that it's aligned again with the gravitational vector down. If the Earth was flat, the gyroscope wouldn't tilt backwards as you go.
But they're just, again, they're tilting backwards just to assume it.
What do you mean they're tilting backwards to assume it? The gyroscopes just do that on their own. That's not a thing that anybody programs them to do.
No. When the early planes were flying, right, and they didn't have one, how are they not?
They probably didn't have gyroscopes.
Well, then how are they navigating?
I don't know, with a compass, I guess, and they were probably just like looking out the window.
And they just got lucky to not crash into the curvature.
Well, no, I mean, if you're looking out the window, then you don't need a gyroscope in order to make sure that you're not crashing into the ground.
Right. So what I'm saying is that it really isn't necessary. They did it without them.
So why do you think that modern planes have gyroscopes?
For navigation.
Okay, so we agree that modern planes use them for a purpose.
Can
you think of the reason why they use them? Like, why do you need a gyroscope when you could just use a compass?
Well, I mean, being in the plane is very different to just walking around, isn't it?
Okay, so then why didn't they need a gyroscope back in the day, before they had gyroscopes?
Well, they didn't. That's a good question.
Look, so maybe this is confusing for you. So what a plane wants to do, if you want to fly, you know, commercial planes, if you want to fly in a like kind of clean way without a whole bunch of bumps and jostles and changes in heights and stuff, what you want to do is you want to set your plane so that it's always 3 degrees if you're flying in a large commercial craft. So it's always 3 degrees above the virtual horizon. That's how you fly a commercial jetliner, 2 or 3 degrees. Now, in order to know that you are angled at the right angle so that you can basically maintain your altitude, which is what the goal is, you don't want to be going up and down all the time, you need to know exactly where the virtual horizon is. And to know exactly where the virtual horizon is, it's not enough to just look out the window, because like our eyes just aren't that good. So instead you build a gyroscope, and then you can display a virtual horizon on your, you know, your dashboard or whatever, and then you can adjust your trim so that your angle relative to the virtual horizon is always 2 or 3 degrees. It's so that you can have better, smoother, more fuel efficient flights. Now, back in the 1940s, I actually don't know when gyroscopes were first introduced to aircraft, but I would imagine it was like the 1920s, 30s, or 40s or something like this. They weren't as concerned with, you know, passenger comfort and maintaining maximum fuel efficiency and stuff, right? They were just trying to figure out how to fly.
For sure. So, but they managed to fly, and they still managed to navigate without it. They didn't crash into the curvature.
So this is interesting. Gyroscopes were first used in planes for stability and control as early as 1909. So I guess it's actually just not the case. I mean, the Wright brothers flew in 1905. What year was that?
Early 1900s, right?
They flew, so there were 6 years before which there were no gyroscopes, and then after that, everybody was using gyroscopes for stability, and like, so...
Right. Are there any stories of people crashing because they didn't account for the curvature of Earth before the gyroscope?
That's not the claim. That's not the claim that the gyroscopes resolve. The gyroscopes aren't there to make sure you don't crash into the curvature of the Earth. The gyroscopes are there to make sure. Okay,
it's
I was
not relevant
explaining.
Either way, is it?
The gyroscopes are there so that you can check to see what altitude you're at. Not altitude, sorry, attitude. How tilted you are, so that you can maintain your constant altitude flight. Right. That's what the gyroscopes are there. It's how then you can make those measurements and adjust accordingly. Because the gyroscope, well, gyroscopes would work fine on a flat Earth. The thing is gyroscopes wouldn't need pendulous vanes.
Yeah, but they don't need pendulous vanes. That's my point.
Then why are they included in the gyroscopes?
Because people think the Earth is curved, so they have to, like, it's like keeping up appearances.
So wait a minute. So you think that
simultaneously that people flew without it, fine.
So simultaneously, you think that the engineers thought that the Earth was curved, but assumed that the Earth was flat?
It just doesn't matter. Like, that's why they literally, there's documents, there's NASA documents, there's military documents talking about
okay, where are the documents?
They constantly assume as flat and stationary Earth.
Can you show me one of these documents?
I mean, I could probably send you to one, yeah.
Yeah, I think I know which one you're referring to. It's the 1980...
It's not just one, there's many.
Well, I mean, there's one that flat earthers like to bring up. Is it this one, perchance?
But it's like virtually all Earth.
I mean, it's actually like virtually none of them. It's exactly this one. This is the only one any flat earther has ever shown me. Here you go. Oh, I don't know why I didn't pull it up. Here we go. It's this one. This is the one that you're talking about.
I mean, it's not.
This is the one that you're talking about, because if you go look at the first sentence, the first sentence says, this report documents the derivation and definition of a linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. This is the one you're talking about, right?
That's one of many, yes.
Okay, can you show me another example?
Not on me right now, but I can send you some, or anyone in the chat.
You can go ahead and minimize the app right now. I'll give you 30 seconds, 45 seconds to go find it, and then you can tell me how to find it, and I'll pull it up. By the way, he doesn't know this, but if you go to page 25, you mentioned this. But this is what he wants to say. He wants to say, they're assuming it's a flat, non-rotating Earth. They're also assuming, of course, that the aircraft is rigid and that the aircraft has constant mass, but that's, they're going to ignore that. I imagine that if they're so prevalent, if they're present in literally all of them, then we probably should have found one by now. But by the way, here's just another one. This is from the FAA. This is a flight manual. Yeah, did you find one?
I found one on Reddit, yeah.
Okay, how do I find it? What's it called?
It's called a flight dynamics summary. There's a PDF.
All right, let's go see if we can find it.
I'd probably be able to link it to you or something somehow. Can I put it in the chat?
Flight dynamics summary. Generally, links don't often go through very well, but we can try it. Is it on the air?
Maybe you found it.
Is it?
I don't know.
Okay, help me out here. Help me find it. So is it one of these reference? One of these over here? Aerodynamics book. It's called a flight dynamics summary. I guess we can put that in quotes. Apparently, there's no book called
you
a flight.
Go to www.aerostudents.com/flight dynamics summary, I think.
Yeah, I think that. Okay, yeah. So this is Reddit, but we want to go to aerostudents.com flight dynamics summary. Okay, let's see.
Yeah, that's probably it.
This one, yeah.
I think that's it.
Okay.
Right?
Yeah. So what page is the flat Earth reference on, or the?
Where's that? There. Right at the bottom. There is a flat Earth. There is a non-rotating Earth.
So what does it say here? Making assumptions.
Is this different to the one that you brought up at the start?
Yeah, I don't think that this is. This is but to be clear, this is not
so
like.
Hold on,
Gladiator.
Multiple.
I just want to go, and we can replay this because I could be wrong about this, but I'm pretty sure that you said that all of the NASA flight documents said this. All of the military flight documents say this.
If I said all, then I was probably wrong. I meant to say many.
Well, but the point is
generalize and
this is not military. This is not NASA, right?
But it's something assuming flight dynamics, and it's assuming a flat.
It's just something. It's this, by the way.
Okay, so handwave.
This is the website.
Okay.
So this is but we can look at this. Let's take a look at what it says. In this summary, we want to describe the flight dynamics with equations. This is, however, very difficult. To simplify it a bit, we have to make some simplifying assumptions. We assume that there is a flat Earth, the Earth's curvature is 0. There is a non-rotating Earth. No Coriolis accelerations and such are present.
That's convenient.
So okay, so you think that do you think that all of the assumptions that are being made here are true?
No. And I'm not using it as proof as, there you go, the Earth's flat.
Okay,
but
so
I'm just saying
do you think that the aircraft has constant mass?
Yeah.
Oh, aircraft don't have constant mass. They lose mass as they burn fuel.
Oh, yeah.
Okay, do you think that the aircraft has a rigid body?
I'd assume it has a very rigid body.
No, aircraft are extraordinarily flexible. I'll show you a aircraft wing flex test.
I mean, something could be flexible and rigid, but...
No, literally, it can't be flexible and rigid. Those two words are mean opposite things. Here's the
I mean, I'm scared of flying, so I want to think a plane's rigid. So my bad on that.
Okay, so we've already established that the aircraft does not indeed have constant mass. The aircraft is not indeed a rigid body. Is the aircraft symmetric?
Probably not perfectly symmetrical, but I'd assume quite symmetric.
The aircraft itself probably is pretty close. It's not going to be perfect, but once you put people in it or cargo in it, it's not going to be anymore, right?
Yeah.
There are no rotating masses like turbines. So do you think that there's no rotating masses on an airplane?
No, I get that there are rotating masses. The problem is with all these ones that you're listing.
Do you think that there's constant wind?
No, it's not constant.
Okay, so literally every single one of these assumptions is false. Why would we think that these assumptions are true?
Because you can prove all those.
Yeah, and you can prove that the Earth isn't flat too.
No, that's a belief.
We've already done it. We've already done it. I mean, we've already done it. But anyway, here, this isn't it. So let's look at this document, right? Oh, actually, I'm just curious. Do you think that that there's gravity? Do you think that gravity is real?
No, I disagree with gravity.
This is the document that you just brought up, which talks about two important kinds of forces: gravity and aerodynamic forces.
Yeah, no, I'm not denying that there's a constant acceleration and agreed upon.
No, but they're talking about gravity, right?
Yeah, but what
they're not just talking about any constant acceleration.
Yeah, but
gravity means something very specific.
What does gravity mean?
It's an attraction of masses.
No, it's not.
Yeah, that's what gravity is. Yeah.
It's literally not even that anymore, right?
It is. It literally is that. It's the phenomenon of mass attracting mass.
No.
There's other stuff as well, but it's literally the phenomenon of mass attracting mass.
Newtonian gravity, right?
Newtonian gravity is a model of gravity.
You're talking about Newtonian gravity, right?
Newtonian gravity is a model of gravity. There's the phenomenon of gravity. No, Newtonian gravity is not the idea of mass attracting mass.
Well,
Newtonian gravity is a model for gravity.
Okay.
It's like an equation.
Mass attracting mass.
That's an observed phenomenon.
You don't want to answer my question.
It's a category error. Nobody came up with it. It's an observed phenomenon. You look out into the world and you see it happening.
Dude,
this is not something that was invented.
The guy that theorized that.
No, he theorized the model of gravity that he came up with.
Yeah, the idea of mass attracting mass.
No, that's not the model. That's the observed phenomenon.
No, it's not. You can't observe.
Is.
No, you're assuming that, man.
No, you can observe this. You can actually observe this. Sure, you can.
Okay, show me an experiment where mass attracts mass.
Yeah, sure.
Also, by the way, that's not even what you should have said. You should have said it's the bending and warping of space-time. That's what
I can assure you I know far more about gravity than you do.
Yeah, you know more about how to be indoctrinated into it.
Okay, so here is, this is an amateur experiment that was conducted by a guy named Blue Marble Science, who has commented on one of my videos, by the way. He's a lovely guy. Actually, I actually don't know that.
Is it the Cavendish experiment?
It is, yeah.
So that's the only thing you guys have is crazy. That's so crazy.
I mean, it's an example. It's an experiment demonstrating mass attracting mass. I'm sorry,
it doesn't even work.
So is your objection? Show me an experiment of mass attracting mass.
Do you have to start
don't show me that experiment.
Do you have to start the Cavendish experiment?
Yeah, it's the best one.
Do you have to push? Do you have to push the balls to start it?
No.
You do.
No, you just put them in place and then they start attracting, right?
And have you removed all other possible interferences?
He was very, very careful. But if you want a more sophisticated experiment, I can show you one.
Electrostatic in the air?
Yeah, so I can show you a more sophisticated experiment that did that. Yeah. Here's a more sophisticated experiment that did that.
Intrinsically electrostatic.
You couldn't even tell me what electrostatic means. Yeah. So here's some more sophisticated experiment that actually does what you want it to do. Wow. This is another version of the Cavendish experiment, but it's at the millimeter scale. And here they accounted for
that mass attracts mass.
Well, because they measured an attractive force between two masses, and they eliminated all of the other sources of possible conflated results. So, for example, by being very, very careful. For example,
okay, so you're not actually explaining anything.
I'm about to explain it. You just have to give me a second, okay? So then I can get to the right part of the paper. So one thing that they do is they isolated the experiment from vibration by putting the entire thing on an optical table with deflated air springs. So like if you shake the ground, the experiment's not going to shake. That's one thing that they did. They also did the entire experiment in a vacuum. So there's no wind that could be blowing things around. They also, okay, that's distance measurement. That's this is talking about calibration of some of their instruments, which we could talk about. They also measured the charges of the masses that they were using so that they could account for any sort of electrostatic forces that are involved. They measure those charges explicitly, and once you know those, they also put an electrostatic shield in place, by the way, which prevented most of the electric fields from being relevant, and then they measured the rest, and then they can subtract off the electromagnetic fields and the forces that they produce from their resulting measurements, so that they can get a electromagnetic free result. They also put the whole thing in a what's it called? Starts with an F. Faraday cage, so that the external magnetic fields and the external noise doesn't affect it. They also used a source of they eliminated sources of mechanical coupling by putting everything basically in a spring system. They eliminated noise sources from the Casimir effect. So yes, they were very, 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 very careful. They removed all sources of all possible sources of alternate causes of the attractive forces, and they still measured an effect. So yeah, sorry.
How did they get rid of all the electrostatics?
They didn't get rid of it. They measured it, and then they subtracted that off from the result. They got rid of most of it. They didn't
So
get rid of all
get
of it.
rid of it then, so it's still present, and that could still be what's affecting it.
No, you don't need to get rid of it. You can just measure it. We know how strong electrostatic forces are, right?
Yeah, stronger than gravity.
So if you know how much charge a thing has, and you know how far apart those things are, then you know exactly what the strength and the direction of the force is between those two things. And so once you've accounted for that force, if there's any extra force, it means it's coming from some other effect.
No, but how do you know that's not the force that's
because there's
creating the
more
result in the
force.
Cavendish?
Because there's more force than is what is caused by the electrostatic effect. I don't know what you're not understanding here.
You're just assuming it's not more. It's more like it's a more different.
No, it is
force.
more.
It could just be the same.
That was the whole point of the experiment. You can do you understand that we very well understand how strong electrostatic forces are for a given charge and distance? There's a nice formula for this. Do you know the formula by chance?
No, I don't know the formula.
Okay.
This isn't really my forte.
Doesn't sound like there's a lot you know. So there's a formula for it. It's very straightforward.
Yeah.
You can measure the charges, you can measure the distances. Once you know those two numbers, I guess it's three numbers really, you can combine them in a formula, and that tells you exactly what the force is. And then you can go measure the force, and the force that you get is bigger than the force that the force that you would get from just the electrostatic force. That means that there's more than one thing involved. It can't just be electrostatics, because if it was just electrostatics, we would get a smaller force.
So how do you know it's the bending and warping of space-time?
That's a cool pivot. This is demonstrating mass attracting mass. Your claim was that you can't demonstrate mass attracting mass
then?
Because we're seeing two masses attract each other.
But yeah, how do you know there's not some other force there?
Oh, there's just some other force that's causing the masses to attract each other.
That's what. Yeah, but that's what you're saying. I'm saying it could be anything like electrostatics.
If there's a force that causes masses to attract each other,
up a force. You're the one
if there's a force, so there is a force that's not electrostatics, that's not magnetic, that is causing these two objects to move closer together. That's what's measured here.
By just assuming that it's not those forces in play. Right.
It's not assuming them, they're accounting for them.
But how's accounting for them eliminate that those are the ones that are in effect?
Okay.
That doesn't make any sense.
And I'll simplify this for you because apparently it's necessary. Let's say that I'm blind, right? I'm like a blind person. Now, I'm at the gym, and there is a, I'm trying to do like progressive overload. I'm trying to hit my 1 rep max, right? Now, I know that my one rep max from last week, I don't know, maybe we're doing bench or something. My 1 rep max is, say, 225, right? For the sake of argument. But I'm blind, and so next week I go in and I ask somebody to put on 250. Maybe I'm just being greedy, right? Can you hear me?
Yeah.
Okay, so I ask somebody to put on the bar 250 because I can't do it, and so then I go try to do my one rep max. Now, if my 1 rep max last week was 225, and I go to try to lift 250, well, it's probably pretty unreasonable for me to think that I can actually lift 250. Instead, it would be reasonable for me to think that somebody's helping me out a little bit. Because I can only do maybe 235. If last week I could do 225, maybe this week I can do 235. But then maybe somebody else is just helping me out a little bit. Maybe my spotter is giving me a little bit of help. So in that case, there would be two forces at play. I would be providing, say, 235 pounds of force, and my spotter would be providing an additional 15 pounds of force. And I could reasonably conclude there's no way I can do 250 if I can only do 225 last week. So I can reasonably conclude somebody either put the wrong amount of weight on the bars or somebody is helping me. You understand the analogy?
Or you could just lift the 250.
Right. Okay. So now imagine that. Now imagine that I go home. I go home to my home gym, and I know what my weights feel like. So I put 250 back on the bar, and I can't lift 250. Then I put 230 on the bar, and I can lift 230. I put 235 on the bar, and I can lift 235. So now I have evidence, now I have reason to think that somebody was helping me at the gym. Because I went home, and when I did it myself, I could only do 235.
Yeah, I get the analogy, but it's not really analogous to this. It's a bit different.
It's perfectly perfectly analogous. And the reason why it's perfectly analogous is because we have centuries of experiments showing exactly how strong the electromagnetic force is. We understand the electromagnetic force better than anything else in the universe. We know exactly how strong it is. And so once you know how strong the electromagnetic force is for, say, these two masses, if you measure more or a different amount of force relative to that force that you know that should be there from the electromagnetic force, then you know that there's something else going on.
Okay, so what's stronger, magnetic force or gravity?
It depends on the charge and it depends on the mass.
So it can fluctuate then?
Yeah, you can have very, very heavy things that have a lot of gravitational force that have no charge, and therefore would have no relevant electric field.
But that means it can fall at different times then?
That means what? What'd you say? Where'd he go? Where'd he go? Did he just fall down the stairs? Oh, he muted himself. I don't know why he muted himself. Welcome back. And he ran. That's fine. We were done with him anyway. All right, let's bring up our next guest. Actually, let's read some super chats first, and then we'll bring up our next guest. I think he may have, I hope he didn't fall down some stairs. You know, he's very dumb, but I don't wish him ill. From Tay Mustard with the $2. I'm into fat Earth theory. We all big and round. Fair. Just making sure he's not coming back. From Juso here with the €2, guest should draw us a figure of how that works. Yeah, he would never do that because he would just be like, oh, well, you can't draw it. Right? From Jack Fetter with the $5, I must admit, dumb sounds much better with an English accent, but it's still just as dumb. Once again, a FLERF loses to perspective. Yeah, that's the thing. Having an English accent just makes people more believable, which, at least for Americans, is probably not a good thing. From Garain with the $5, anytime a FLERF uses perspective, we need to force them to define what that actually means and works. Yeah, I mean, we could, but then it just gets into a semantic debate. From Empiricist with the $2, does he think maps should show further things small? Yes, he does. From Ekipo with the €2, once again, any pilot, millions of people. Yeah, I mean, like, there are tons of pilots who will absolutely tell you that the Earth is a globe. From Clown Meat with the $5, if you've ever seen a tire drive through water, you've seen water sticking to a partial ball. Yeah, and in fact, you can just dunk a tennis ball in the water and water will stick to it. From Nekdu with the $5, the pilot told me just to hop on his back, we could take off, and I said, what? He then said, it's okay, I'm an airplane. Pilots are airplanes these days, y'all. From Eat Some Shorts with the $2.25, second biggest flex to the PhD is putting up $2.25. Oh, I can't do $2.25. From Scrung with the $5, the weight analogy is actually generous because we know exactly how magnetic forces work and your ability to lift weights is incredibly variable. Yeah, I was trying to be generous. And from Philo Dragon with the $5, I can see where this is headed. Oh goodness, look at the time. All right, let's bring up our next guest. Topograph, how's it going?
Hey, can you hear me?
I can hear you just fine, Topograph. So, Topograph, what shape do you think the Earth is?
It's flat.
All right, why do you think it's flat? Also, your mic is kind of low, so let me turn you up a little bit.
Yeah,
Why do you think it's... Go
I
ahead.
was just listening to you. I was just listening to you explain away the pendulous vanes. It's funny how you
explain the
figured,
pendulous vanes? Yeah, sure.
yeah,
Go ahead.
explain away. Like, you know,
He
pendulous
didn't even know what
vanes.
they were. How was I explaining away when he didn't even bring them up?
I was saying, you say it's not even required. He says, yeah, it's not required. It's for gravity. You said, yeah, but it is. And then you go into gravity, you know, from one lie to the other lie. And I see you jump around. Here's the kicker.
Sorry, what's
Okay,
the
the
lie?
pendulous vanes. You go from pendulous vanes. He says, oh, it's for to compensate for the gravity or something. He said, you know, and then you said, oh well, gravity. Yeah, did you believe in it? And then you go to Newtonian gravity and so on and so
Okay,
forth.
so
and all that.
you're
all that
just
stuff.
upset that I'm talking about science instead of like your fantasy?
No. I'm upset about your pseudoscience.
Oh, the pseudoscience.
Yeah,
Okay, so
yeah.
can you tell me how electrostatics work?
Well, let's stay with the pendulous
Because I mean,
vanes for a minute.
clearly, I don't know a lot
Let's
about
stay with the
electrostatics, so I'd love you to tell me about them.
No. Why don't we stay with the pendulous vanes so I can nail you good?
Okay, tell me about pendulous vanes.
So, what does the pendulous vanes do exactly?
My understanding is that they essentially use little ports that open up. I'm explaining, don't interrupt. They use ports that open up when the gyroscope is not aligned with the gravitational force vector. They use little ports that open up that let air flow in, that applies a torque to the gyroscope to reorient it so that it's pointing in the correct direction. It's aligned with the gravitational force.
Okay, I see you don't understand how a pendulous vane structure is.
Okay,
so you said there's holes.
Did I get wrong?
Okay, maybe I'm wrong. I'll help myself to understand the way you understand it. So you just said there's ports that are open. What do you mean by ports that are open?
Well, no, the ports aren't always open. They open depending on how the gyroscope is tilted relative to the gravitational field. No, that's my understanding.
Are the ports in line?
Are they in line with what?
Oh, so you don't know that?
No, I don't understand the question. Are they in line with what?
So.
By the way, here's a diagram.
Yeah, well, you don't have to show me that, but I know how this stuff works. So the ports are literally, the ports are diametrically opposite, but they're offset off of each other, and there are two of those 90 degrees apart.
Sure.
And these limiters that are
What did I say that was wrong?
No. I asked you said the ports that are open. The ports are always
No, I said that the ports can open.
Oh, well, okay, sure, I'll give you that. So now you're trying to jump and fill the gaps. So go ahead and explain to me.
Those are the words that I used.
No. Yeah, sure. Okay, explain to me what exactly those ports do.
They allow air in, is my understanding.
Well, and just
I guess it's exhaust air.
No, no, you're wrong over there too.
Maybe they only allow air out. Maybe they force air through it in the other direction. I don't know. Which one is it? You tell me.
The function for the air to go out, there's already slots. There's already slots cut in the pendulous vane structure.
Yeah. So does the air go in or does air go out? Does air go out? Does air go out or does air go in? You tell me.
No, there's a purpose for those slots. I'm still not getting it from you.
No, I'm asking. Does air go in or does air go out?
No. Listen carefully. What is the purpose of those slots?
Does air go in or does air go out? You tell me.
No, you just explained to me what is the purpose of that slot exactly.
So the airflow is there to apply a torque to the gyroscope so that it's reoriented so that the force vector and the gyroscope are realigned.
Okay, good. That's good. You're getting that.
That's what the pendulous vanes are for. Now the actual the detailed mechanisms, I can't tell you about that.
So
I've never taken one apart.
Hold on. What do you mean by reorienting? What does that mean?
So if the gyroscope is not aligned with the force vector, then you can reorient the gyroscope so that it is aligned with the force vector.
Why do you have to align it with why do you have to align it?
Because you want to produce a virtual, what's it called? A virtual horizon that is in alignment with what you actually are flying over.
Oh, you have to produce a virtual horizon? What do you mean by that?
That's what the gyroscope does. It's there to give you your virtual horizon.
So the bottom line is here. The bottom line is this. You're absolutely ignorant about it.
Okay, so tell me, what's the purpose of the gyroscope?
You are so ignorant about the topic, but you blabber around.
Because this is what you do. Listen, hey, topograph. Tell me, what's the purpose of the gyroscope? You can answer the question once you answer or you can continue once you answer the purpose of the gyroscope. Okay? And we're going to test you because maybe I'm wrong. I'm not an aircraft mechanic. Oh, wait a minute. You're the guy who lied about being an aircraft engineer. That's right. What is the purpose of an aircraft gyroscope? I'm just going to type this into Google. It's to provide a stable, reliable reference. What's that called? What is the stable, reliable reference called? It's called a virtual horizon. for the pilot to determine the aircraft's attitude, pitch and roll, heading, and turn rate, even when outside visual references are obscured.
So you're
what is that
muting me.
reliable reference called?
So you're muting me. So you're muting me. So people don't understand that how much of an idiot you are. Hey, listen.
What is that reliable reference called?
Hey, genius. Hey, you explain to me how a gyro works. Hey, genius. Explain to me how a gyro works. Still,
how a gyro works? A gyroscope. Yeah. A gyroscope is just anything with a ton.
It's just anything. It's just anything, right?
Oh, you know, it would sound stupid if you only listened to the first 4 words, but unfortunately, that wasn't the end of my sentence. So a gyroscope is literally anything that has sufficiently large angular momentum that it's not going to be substantially affected by random jitters, and so it will maintain an orientation in space.
Wow, you are really technically capable, man. You are such a technically capable person.
I know.
No wonder
why
you're. No wonder why you just have your stupid PhD sitting online on TikTok and bullshitting with everybody else and collecting chump change.
I am really technically capable.
Yeah, right. You know what?
I'm glad
not going to
so.
educate you. You know what? Listen, I'm not even going to educate you.
Do you want to see my most recent solo paper?
I don't care about your stupid PhDs. You're ignorant as fuck to me, okay? Because you don't explain a gyroscope properly. You don't understand how a gyroscope works. You're an idiot.
I was telling you the principle of
you come here.
You principle of a gyroscope. Yeah, definitely.
No, I don't want to hear. You already said it. You already said it.
I know you don't want to hear it. I was explaining to you how a gyroscope works. If you think that it works some other way, then that's on you, buddy.
You just said it's just.
Topograph, you came up here really, really salty. It seems like that you're probably a little bit self-conscious about the fact that you don't. I'm sorry. It says that I have to remove him, and I should have been paying attention earlier, but I needed to remove him from for violating something. It said remove Topograph because, and now the live is restricted. Lovely. Love that for us. That's a bummer because that was a good crash out too, and I wanted to keep him on. Still can go on YouTube though. All right. I really need to stop hiding the windows. Like the I have my monitor over here is the one that tells me when there's somebody needs to be removed, because that gets me in trouble a lot. I don't think it was because he was using swear words. I just want to double check something, y'all. Okay. Let us read some super chats. And, oh, no, there's a few super chats. Then we'll bring up our next guest. From Sayonology with the $2, you can lift heavy. You carry Science.com on your back. Well, I appreciate that. That's very sweet. And from Sebastian with the 20 Swedish kroners. I really enjoy the rhetoric and the analogies. Analogies are king. Sorry, just responding to my wife's text message. Yeah, I think that I'm pretty convinced that Parallax is pretty embarrassed. Now, I should probably hydrate a little bit more, but we do have a very special guest that we're going to bring up to, you know, talk to you guys while I'm hydrating.
Hello. As the real-life human brother of Dr. Blitz with authentic human kidneys and emotions, I use my biological human eyes to watch this live just like everyone else. In order to give them a short break from perspective deceiving me about the true nature of reality, I'm here to talk to you about why you should support the live. Just like any typical human, immediately upon coming into existence, I had many questions. Who am I? Why am I here? How do gyroscopes work? Thankfully, lives like this are able to answer at least 2 of those questions. To ensure questions like this continue to get answered for other fellow humans, it is important to show your support for the live. A good way to do that is to subscribe, send gifts or super chat, or use things like Patreon or Cash App with links near the bottom of his website, blitz.phd. If you are a fellow human who cannot currently subscribe, you can always show your support by following the channel, liking the live, leaving comments, and sharing the live and his videos with others. Also, you can join his Discord to become a part of the community and receive notifications when he plans to go live. By joining, you can participate by suggesting new video topics and sharing funny memes. Thank you all for listening. Now that my flesh eyes have been given the break that all human organs require, I can go back to watching the live like everyone else.
I hope you guys really enjoyed my real human brother while I was drinking some water. Definitely not a ventriloquist dummy. That would be an absurd thing to do on a live stream, surely. We do have 2 more super chats to read, and then we'll bring on our next guest. From C-Bar with the $2, here's some chump change, but I still love you, Blitz. I appreciate the chump change. The chump change is very much appreciated. You guys who send me chump change, you're the best. I love the chump change. I know that some people have sent hundreds of dollars before, and surely that's chump change for this guy, whatever his name was, Topograph. He surely is making way more than that at his, you know, technician job at some aeronautical firm, right? Definitely chump change. From Jack Fetter with the $5. What is the airspeed velocity of an unladen swallow? Don't know? Hack! I do know. But first you have to answer African or European. All right, let's bring up Vaziona. Vaziona, how's it going?
Yeah, hey.
Vaziona, what shape do you think the Earth is?
Obviously spherical, but that's not what I want to discuss. What I want to discuss was aerodynamics.
Okay, but the topic is the shape of the Earth, so I'm going to let you go. Let's talk to Grim. Remember, please join the live stream only if you think that the Earth is flat. Grim, how's it going?
Hello, hello.
Grim?
Yep, if you can hear me clearly here. Before I do start speaking, I want to quickly ask if you can hear my fan, and if that is a distraction, then I can turn it off for now.
Sounds fine to me. Do you think that the Earth is flat, Grim?
So I do appreciate your feedback. Now, I do not feel like the Earth is flat, but I do not feel like the flat Earth theory is dead.
Okay, but look, so you can make a sociological point if you want. Well, actually, no, you can't, but that's not what the point of the live stream is, so I'm going to let you go. But thanks for being here, Grim. Let's talk to Maghreb. Maghreb, how's it going?
Hey, what's up, Blitz?
Not a whole lot.
Long
Maghreb,
see you anymore.
what shape do you think the Earth is?
The Earth is flat.
Okay, why do you think so?
It's a flat surface, and it's a kingdom. It's not a planet.
Okay, why do you think so?
Go. Because we are the Abrahamic system. We are the first scientist people on Earth. We have, I mean, we invented science and math and geography, cartography, physics, everything. So you're talking to the Abrahamic descendants. Yeah,
so
we are back actually.
Maybe
you see what I'm saying, Blitz? You understand
maybe you just didn't
and
understand.
Donald Trump is with us. Donald Trump is with he's with us. So pay attention.
Maghreb.
Yeah, go ahead. Yeah, go ahead.
We're trying to do a back and forth here. So maybe you just didn't understand the question I was asking you, which is normal. So the point, what I'm asking you is not, you know, what's the historical significance of the flat Earth belief? What I'm asking you is, what's the evidence?
Yeah, the evidence is the flat surface. It's a flat surface. It's not a planet. So the Earth cannot be a planet. So that's the problem now.
That's the claim.
Earth is not a planet. So the Earth, you're saying the Earth is a planet right now?
What's the evidence that
the Earth is not a planet?
What is the evidence of that?
Because the Earth is a kingdom. It's not a planet. It's not a star.
What's the evidence of that,
my friend?
What's the evidence
Blitz,
of that?
open your mind. I mean, open your eyes. I mean, open your ears.
Maghreb, what's the evidence? You just keep saying the same thing over and over again. What's the evidence?
What you mean the evidence? Is the Earth a star?
Yeah, like is there some set of observations, some set of experiments, some collection of data that you've done to come to a conclusion?
We come about the observation of the sunset and sunrise. Don't worry. You're talking to an Abrahamic system, by the way. You know, we are the Abrahamic religious.
Wait, hold on.
We are the Abrahamic religious. You see what I'm saying?
Abrahamic system? Are you an AI?
No, I'm not an AI. I'm a religious. You know, I'm the punishment guy. I'm the guy who gives the punishment. You see what I'm saying?
No, I have no idea what you're saying.
Okay, so is the Earth a star? Is the Earth a star? Go ahead, answer my question in front of these people, man.
No, the Earth is obviously not a star.
Oh, so the Earth is not a star. So what does a planet mean then? Why you call it a planet then?
A planet is a small-ish body that orbits a star.
That orbits a star?
Yeah, it's a non-stellar object that orbits a star. It's able to clear out its environment. Okay. It has enough gravity to make itself circular. And there's a third criterion that I don't remember.
Okay, do you know that planet produce light?
They reflect light, yeah.
No, it's not reflecting. Oh, hey, bro, don't be. Come on, man. Are you serious right now? Blitz, come on, open the, again. Is the Earth?
This has got to be a troll, by the way. Like it's
light?
like the most obvious troll I've ever heard.
Okay, leave this question. Do you know what is a
like
solar apex?
Maghreb. Sorry, how do you feel about how do you feel about freedom fries?
No. Just what I don't understand this. What you say right now? Say that again. Say this again.
How do you feel about freedom fries? Do you speak French?
Je parle pas bien français, mais j'ai pas bien compris.
Okay, just give me 1 sec, okay?
No problem, but don't run from my questions. I said just for your for your audience, I'm the best geographer, so I have to prove this. And don't run, man. Don't run, bro.
Hold on.
The house is crying right now.
There's a really important question. Can you 1 sec?
Yeah, no problem. You're welcome, Blitz.
I'm just trying to find something that particularly particularly funny.
No problem, Blitz.
Because I don't remember it off the top of my head.
I like your personality, but your research, bro, it's totally like a Viking or something else or something like that, bro. But your personality is okay, man. I like it, you know.
So can you? And look, this is not optimal, but it's the best I can do, the best I can find at a moment's notice. What is the name of the sea mammal that gets like eaten by killer whales and it goes or what's the name of that animal?
I don't know. You mean dinosaur or something like that?
No, it lives in like the cold part of the world with like, and it jumps up onto the, it gets eaten by orcas, and it has a little cute dog face. What's the name of that?
I swear I don't deal with that, bro. I have nothing with this. Is it a French thing or something?
Well, I just want to know what the word for it is in French. It's the word. It's a seal, right? So what's the word for seal in French?
Seal.
Oh my god.
I don't know.
Oh my god, the bit's dying because you don't know what a seal is.
You can translate this, man. Where you go to? Come on. I start with.
You guys you're the worst.
No, we are not the worst. We didn't do nothing yet, man. We coming. You didn't see nothing from the Abrahamic system, my friend. Please.
You're coming?
You didn't see nothing yet, man. You're gonna see a lot.
Wait, you're coming?
What you mean you're coming?
Do not come. Do not come. Do not come. Do not come.
What's going on now? I believe someone is hacking you, man.
All right, we can move on here. Sorry, I just had to like. There's a great phrase that you could. It's like what is it? It's something 210, and there's a phrase that you can ask a French person to say, and it sounds very funny to English speakers. So, anyway, that's what I was trying to get him to do, but he probably couldn't translate things. All right, let's bring up Ovidusk. The bit failed. Okay, we tried. Ovidusk, how's it going?
I'm okay, man. I'm good.
Glad to hear it. Ovidusk, what shape do you think the Earth is?
Yeah, I believe the Earth is flat.
Okay, have we spoken before?
No, I tried to, but I didn't get it because you got a lot of people around.
Well, here we are. So, Ovidusk, you think the Earth is flat?
Yes.
Why?
Because of the science that we can do on Earth here without believing things that you cannot measure or try to yourself. I'm sorry, I'm not English. I'm not American or England, from England, whatever.
It's fine, Ovidusk.
So for me,
did you know that we can measure gravity ourselves?
I don't agree with that. I think we can measure the speed that things fall. I don't believe that's gravity. I think that's
no, that's not what I'm talking about. I'm talking about measuring two objects attracting each other. We can measure that.
I've seen some experiments, I think. I read something, but I do not believe it because you cannot, in my opinion, you cannot put two big things here on Earth and watch them attract each other. But I
thought you said that you only believe the things that you can do yourself, but you can do this yourself.
Yeah. How? Give me an experiment.
It's called a Cavendish experiment, and there's a guy on YouTube that did it in his garage. Let me show you. And you should go watch this video, by the way. It's very, very well done.
Yeah, I will.
So here's it. It's done by Blue Marble Science. If you don't know who it's done by.
No.
It's like a 25-minute video, but he details a lot of the steps, and it's not the full thing. But here's the actual apparatus. So see how there's like the big. Yeah, there's like the big heavy ball there. You can't see this, sorry.
I don't,
There we go. There's the big heavy ball there, and then there's a little tiny ball there, and then there's another little tiny ball there, and then there's a big heavy ball behind it. You can see the heavy ball here. You can see the little baby ball there. Actually, and so, sorry, those are the, what do you mean you don't trust? This is a guy's garage. And so what he did is he then used this apparatus to measure the position. Like when the balls are close, you can measure their attractive force, and when balls are far away, you can measure their failure to attract each other. And what he does is he just
some kind of electromagnetism, I believe, in sort of way. I do not believe.
Can you tell me what electromagnetism is?
No, not really. But I was trying.
So then, why do you believe it is?
I was
why do you believe it's electromagnetism?
I believe the Earth is flat because there's no measurable curvature. That's my first belief.
Sure, there is. I can show you that too. But just to be clear, do we now agree that you absolutely can measure gravity?
No, I don't believe that. I don't believe like you don't believe experiments.
I just showed you a guy. Wait a minute. Hold on. So I imagined that you would like a YouTuber doing the experiment because it shows that anybody can do it. But I can show you scientists doing a very, very sophisticated version of the same experiment if you want. I can show you the paper that they wrote. It's not just some YouTuber. This is a real thing that scientists do. He was doing a less sophisticated version of the same experiment. Now, if you want me to show you measuring curvature explicitly, there's a guy that does that too. He's a surveyor. His name is Baron Rutledge. His job, keep in mind, his day job is measuring the Earth. That's what a surveyor does. So let me show you. Here's a video of him doing this measurement.
Can we talk a bit?
Well, you said that there's no experiments showing the curvature of the Earth, and here's a measurement.
I can show you many experiments that done just like this over the water with lasers that show
I don't think that you can show me any measurements using lasers. What you can show me is you can show me videos with lasers, but no actual measurements. So he's actually using equipment to make measurements, right?
Yeah, because they measured the height on the island, on the first island, and when the laser struck on the other island, it was the same height.
Oh, that's funny.
You can measure.
So I mean, we can talk about that, but why don't we talk about this first? So
I don't know what's that. I don't know. I have to watch the whole video.
I'm going to explain it to you.
It's 7 minutes. It's
4 minutes.
7 minutes video. Leave it.
This is 4 minutes. Okay. I'm gonna show you. I'm just going to explain it to you because I can't play the audio. If I do, I'll get demonetized.
Yeah, exactly.
So don't say exactly what. So this is he's an acquaintance of mine. I don't know him personally, but we've chatted a few times. So he's a surveyor. So what he does is he goes over to a lake. It's actually a lake that's pretty local to me. It's called Lake Mead. And the first thing that he does is he sets up a target on one end of the lake. Now the lake, it's a pretty big lake, but one part of the lake, the part of the lake that he's using is a mile across. So he sets up a target in the water. And he measures it, so it's exactly 61 inches above the water. You can see that here. So the target is that black arrow. It's 61 inches above the surface of the water. You can even see him. You can even see him how he's doing the measurement there. So it's 61 inches above the surface of the water.
Is that a camera? What's that? A camera?
It's just a target. It's just a thing that he's going to be looking at it. Yeah, it's just an object. It's an object that is precisely 61 inches above the surface of the water. Now, so, and he also gives us his coordinates. His GPS coordinates are down there at the bottom. Fine.
Yeah.
And so then he goes over to the other side, a mile away.
Yeah.
He put another nail in the water so that he can measure from the surface of the water accurately. Sorry, I just want to skip it. Yeah, so now he's on the other side. He has a nail in the water. He can measure from the nail to the observation point. Now, this is the thing that he's going to observe with. It's not a camera. Think of it like a telescope with dashed lines in it so you can see how high things are.
I know what it is. I know what it is.
Auto level. So we're going to check we're going to check how high the auto level is above the surface of the water. It's 61 inches. That's his latitude, so you can figure out how far away he is if you wanted to plug it in. It's about a mile away. Now he's going to look through this this auto level, and he's looking at the target. Now it's kind of hard to see here because it's zoomed out, but here's a zoomed in picture of the same thing right there. Now the pink thing, pink thing is the target. That's the thing that he was looking at. That black line that goes across the screen, that is that's where it should be if it was 61 inches up, because the auto level is 61 inches up. And at the other end of the water, the other thing is also 61 inches up. So if it was indeed, if the water was indeed not curving, then this pink target should have been at the black line, but it's not.
On the black line. Okay. Right. Can I answer that? It's very simple.
Yeah, please.
Very simple. I believe that the objects in that picture, it's lower because of the water in the atmosphere, which causes refraction and makes light bend downwards, just like the sun sets because of refraction. That's what I believe. That's why you. One second.
Great.
Can I?
It's a great claim.
Can I say something else, please?
Is it going to be about refraction?
It's going to be about this effect. Yes, this is an effect. Okay. So if you go to a football pitch, you go to a football pitch and you put your head on your side to one goal and look at the other goal and put your friend walking towards the other goal, you're going to see his feet disappear. Why?
Oh, wait, hold on. That's a claim. It seems unrelated.
No. It's what do you mean? You can
that's not true.
Of the pitch. Well, it's true. Absolutely. I done it myself. I've done it myself. I've done it on my football pitch here in my hometown. I did
on
it.
Your football pitch there in your hometown. Got it.
Yeah. Excuse my English. I'm trying.
I understand, and honestly, your English is better than. Well, I don't know what your first language is, but your English is better than.
Romanian. I'm Romanian.
So your English is surely better than my Romanian. I'll give you that much. So look, the point is I've seen videos of this this claim where people are like, put a camera down low at like on like a running track or whatever, and you'll see their feet disappear first, and it's false. It doesn't actually happen. I've done an analysis of the videos, but let's talk about refraction, okay? So. You think that refraction is a real thing? Refraction is a real thing. Let's talk about it. Oh, he left. Okay, well, we're going to explain it anyway because it deserves explanation. That's very unfortunate that he ran. But okay, we'll talk about diffraction just here for a minute, and then we'll move on to our next guest, just so that you guys get the education. So the claim is we're going to use orange for the sunlight. So the claim is if there was no refraction, that's too small. If there was no refraction, then it should be that the top of this mountain, say, would shine light directly into my face. And so I would have to look up at a certain angle. The angle I'd have to look up at is given by this angle, right? Whatever that angle is, that's how much I would have to look up from horizontal in order to see the top of the mountain. However, the claim now is that the sunlight that the light bends down. So let's simulate that. It starts from the top of the mountain, and then it gets to my eyeball, but it bends down. See how now the light is bending downward? Yeah, something like, well, it's not perfect because this is not great software, but if I do something like this, that's obviously very extreme, but now it's bending downwards. Oops, come on, stop it. Now it's bending downwards, right? That's what he was claiming is happening. But if we are then seeing the ray going there, well, then it looks like it. Wow, I'm 32 and I can't believe that just happened. What that means is that it looks like that the top of the mountain is way up here, because you would follow back the angle that you have to look up at. That's how you determine how high something appears to be. And so what that means is that because of refraction, you'd have to look up higher because it's bending down to you. And so, in fact, if refraction was causing the effect that he was suggesting, then the object that they were looking at in the video should have been higher rather than lower. So refraction doesn't save the day there. And now you know why. All right, let's bring up our next guest. I mean, the guy, so it's not a globe claim. He just made the claim of refraction. I was just explaining how refraction doesn't save his argument. Close out of that. He didn't crash out. No, he just ran. All right, from No More Breakdowns with the $5. Is tangent calcs of Polaris for multiple observers a straight up smoking gun against the flat plane? Yeah, unless they believe that the light is being bendy wendy, which they do. And from Orion Cooper with the $2, soccer fields are never flat for drainage reasons. Yeah, that sounds probably right. So, I mean, that's why we can use the surface of water if you want, right? All right, let's bring up Jacob Miller. Jacob Miller, how's it going?
Good. You?
I'm doing all right. Jacob, what shape do you think the Earth is?
I think it is flat with a dome.
Okay. Why do you think that?
Because I believe life is a simulation, and
Your friends are laughing
I
at
have
you.
multiple points. Yeah, they are. I know. But
Do your friends think that it's silly to believe that Earth is flat with a dome?
Oh, they do. Yeah.
Okay. But you still believe it, even though your friends think it's kind of dumb.
Yes. I'm just smarter than them.
Okay. What do they think? Do they think that you're smarter than them?
Yeah.
Okay, I'm sure.
I think he's like retarded.
Oh, bro. I mean, he was a troll anyway, so I wasn't going to let him continue for long, but you can't... I mean, like, I get that your friend didn't know that, but you can't say that. By the way, mods, the Bass Guy official, he is currently in the guest box. He is also the Bass Guy.
Yo. How are you?
I'm just letting you up here so that my mod team can ban you.
I know.
Okay.
Dude, does Lake Mead have bass in it? Dude, wait, can you
Mods.
at least answer the question?
Mods, you know what to do.
Have you ever caught a bass? Please.
It's gone. He's gone. All right, let's talk to Mr. Theodore. All right. Oh, shoot. There's a guy in Discord. Fro, how's it going? Oh, we've spoken before, Fro. Fro, you are no longer in the guest box.
Sorry.
You're good. Fro, we've spoken before. Was it recent, and was it on this topic?
No, it wasn't on this topic at all.
Okay. Fro, what shape do you think the Earth is?
I think it's round, but your question on YouTube, your question is, or your statement is that flat Earth is dead.
Yep.
Clearly not dead.
Well, it's dead insofar as nobody takes it seriously anymore. But I'm going to let you go, Fro, because it doesn't seem like that you want to disagree here. Or that you think that the Earth is flat.
So mean to me?
Because I hate you personally. I think that you're a bad person.
I just want to know if you.
I think that you're a genuinely bad person.
I'll leave you alone.
What did Bass Guy do? Wasted my time. That's what he did. All right, guest box is currently empty. So if you think that the Earth is flat, and you think that you have an argument that, you know, maybe it'll bring me over to the flat side, feel free to hop up. Otherwise, I'll just assume that all of the flat earthers that are in the chat, and by the way, there are many. My guess is probably at least 100. Many flat earthers. If you think the Earth is flat, feel free to come up and defend it. Otherwise, I'm just going to assume you're a coward. All right, let's bring up... Oh, can we bring up Charlie? Oh, I don't think that Charlie is actually serious. Dr. Blitz, why do you think the Earth is flat? I don't think the Earth is flat. You should debate Eternal Light. I have no idea who that is. Lake Mead has striped bass. I bet they do. I bet Lake Mead does have that. You generally believe there are 100 people who truly believe the Earth is flat. I feel like maybe less than 10 are serious. No, there are a lot of serious flat earthers. Dr. Blitz debunks tides disprove a flat Earth. They can be at different levels at the same time here in Nova Scotia. Yes, they absolutely do. They just don't like that. You should debate Angels of Light. Oh, if you didn't know, Vincenza, if you didn't know, happy to share this because I'm, you know, it's very, very fun. I have debated Angels of Light. In fact, I've debated him in a formal setting. And it was on Modern Day Debate, actually. And everybody should go watch it because it's so funny because they did so poorly. They did so unimaginably badly that only the Globers actually, like, you will never see Angel of Light brag about his showing here. You will never, ever see it. But I bring this up whenever I get the opportunity to, because he got smoked. So yeah, this was on Modern Day Debate with Angel of Light and Nathan Thompson. Nathan Thompson, by the way, being the person who allegedly harassed children with his flat Earth stuff. So that's me over there. Not a great angle, but and that's Angel of Light over there with his headphones on, right? So go watch that if you haven't. It's on Modern Day Debate. It was about a year ago or so. Look up my name, Angels of Light, or Angel of Light, or look up my name, look up Angel, look up Modern Day Debate. You'll find it. Make sure that everything's up to date. Angels of Shite. That is very funny. It is on YouTube. Yeah. Love to hear your take on Globe Crusher. I don't even know who that is. Well, look, I don't want to say something if he wasn't convicted. I don't want to say that he did a crime if he wasn't convicted of the crime, right? I say it's alleged because I think he was charged with a crime, or he was charged or something, or detained at least. Yeah, thanks for playing. How long is the video? It's like 3 hours long. Thompson saw jail time over it? Really? Is that really true? I know he was arrested. Here, let's just read. Flat Earth advocate arrested after yelling at Greenville County Elementary School students. He videoed it, by the way. And he was reaching over the fence the video shows him reaching over the fence to hand them flyers before yelling out, "Space is fake! You're not on a spinning ball." He was arrested by Greenville County deputies and charged with public disorderly conduct in relation to the incident. He said, "I'm gonna flat smack them to children," which is a crazy thing to say. In the video, of course. I don't actually know if he saw jail time over it. I don't know if it's gonna say that here. Let's just. This was in Arizona? There's no way this was in Arizona, right? Or is this a different? Okay, that's a different Nathan Thompson. This person. Oh, wait a minute. Hold on. This person says that he was arrested and goes to jail, but I'm not seeing anything, any news articles or anything like that. Apparently, there was another Nathan Thompson that did go to jail for other stuff, but yeah, you know, I'm happy to hedge my bets here. I don't want to say anything that's legally dangerous. The question is if you think Earth is flat is not dead, not if you're a FLERF, no? Yeah, but it should be pretty clear what I'm getting at here, right? Nobody was harassing. I mean, yelling at children is kind of like, okay, maybe it's not legally harassing, but like it's definitely like harassing colloquially, right? No one censored flat Earth videos. They dropped off the algorithm because nobody looks at flat Earth videos and takes it seriously because it's an unserious topic. Yeah, that's what I mean by it's dead. Globe Crusher is Fred? Wait, I thought Fred was, oh, Fred, not Freddy. Okay. I know who Freddy is. Greenville is in North Carolina. Okay, now I know. Now I know. You gotta believe flat Earth is the shape of the Earth, not just that the theory is still around. Yeah, that's the idea. I saw a 1960s era video where they pulled a large weight underneath a scale and it showed 0.01 g increase in weight, but the math doesn't math. So probably what's happening here is that the math does math, but it was just really, really close to the cutoff where it rounds. All right, well, if there's no flat earthers in here, which I'm pretty sure that there are flat earthers in here, but if there's no proud flat earthers in here, which, you know, I'm sure that there aren't any, because why would you be proud to be a flat earther? Then, you know, we can just change the topic. I mean, that's not the end of the world, right? Greenville, South Carolina. Okay, yeah, I know. Because the live got restricted? No, it was only a temporary thing, I think. I didn't even see like an option to like appeal it. We still have like 600. We have like nearly 700 people in here, so it's not because it got restricted. I guess we could restart the live on TikTok. That's not the end of the world. Find the video. They come in at like 2 a.m. Central. Yeah, they do. Yeah, I guess Globe wins by default. Right. I can't access the request, so that may be why. The request box should be working, right? I think it's working for everybody. No? Okay, yeah, it's working for at least one person. Sick Jason just joined, so it is working. So there's no issue there. If there's no box for you, then that might be because you don't have access. It's not like a personal thing. I actually don't know if Sick Jason wants to actually discuss. Sick, were you just checking out the box, making sure that the box works?
I was just checking out the box for you, Blitz.
All right, I appreciate it. Thanks for being here.
Yes, sir.
All right, let's talk to Lunar. Oh, nope. Yeah, so the box is working, everybody. Don't worry. Also, there is a Twitch stream. There is a Twitch stream is relevant. There is a Discord room that you can join if you don't want to join on TikTok. The link is down in the description. You can find it in various ways. All right, well, let us mildly change the topic. Or, oh, never mind. We have a guest from the Discord. Tiny Frank, how's it going? Tiny Frank?
Yeah, I was listening to you like double it.
Tiny Frank, I can hear you. What shape do you think the Earth is?
Right. Give me a second, please.
Okay.
Yeah. So, I don't know if you already changed topics.
I have not.
But all right. But well, this is maybe related.
What shape do you think the Earth is, Frank?
I generally believe it's a sphere, but I cannot prove it by myself. Like I have very well trusting in institutions. Like
Okay.
I believe most of people do, right?
Yeah, I mean, like, there's a lot of different experiments that you could run to prove that the Earth is a sphere. But honestly, like, we just have, like, we have photos. We have so many photos, so many videos of the Earth being a sphere.
Oh, yeah.
Like, even independent ones run by, like, independent random amateurs on YouTube who send a rocket up, you know, to space. Like, this exists. So.
Oh, yeah, I know. That's.
But Tiny Frank, it looks like that we're not in disagreement here, so I'm gonna let you go. All right, let's bring up Entropic Angel.
Hi,
Entropic
and
Angel.
I believe in Scientology and Xenu.
Okay, what shape do you think the Earth is?
Flat.
I don't
It's
think that
because I
Scientology is
believe in the
compatible with flat Earths.
iceberg theory.
I don't think that
I
Scientology
believe
is compatible with
dragons
the...
exist and hydras exist.
Mods, you know what to do. You know what to do, Mods. Let's read some super chats, because we have a few. From Baba Llama with the €2. Have you ever converted a flat earther? I've converted people who are on the fence. And from Emil SRR with the €2. When was this bass incident? I missed the lore. There's not really any lore. It's just a troll that comes up and just asks if I can, you know, catch a bass and hook it or whatever. Like, he's just a troll who just has like 100 accounts, so he just does it all the time with different names. So it's less lore and more just like an annoying waste of time. All right, well, here's what we're going to do. We only have like an hour left. So actually, you know what we'll do? We will convert, we will switch over, change topics slightly, because I actually am going to be occupied this Wednesday. I won't be able to do my Ask a Physicist live on Wednesday, because I'm going to an acquaintance's, perhaps a friend even. I'm going to their thesis defense. So we're going to do Ask a Physicist for an hour. So that means I'm not going to be taking guests, but I am happy to answer questions. Obviously, super chats do get priority. We don't need the URL anymore because I'm not taking guests right now. But for the next hour or so, I'm happy to answer questions. Kerbal still tomorrow? Possibly. Yeah, at least for an hour and a half. We'll see. Isn't a sphere topologically equivalent to a disk? No, a sphere has a boundary, or a disk has a boundary, a sphere does not. Are we doing an hour of KSP now too? No, we're not doing an hour of KSP now, just answering questions. From Masterminder with the $2. Okay, but Blitz, have you ever caught a bass? I've never caught a bass, no. No, I've never caught a bass. No, not KSP now. No, not KSP now, just regular Ask a Physicist. People do have questions that they want answered. I would like to know what your thoughts on what the Great Attractor may be. It seems likely that it's just a big galaxy cluster that we can't see because our galaxy is in the way. From DeButcher with the $5, what's the best paradox about physics in your opinion? Well, there should be no paradoxes in physics genuinely. Because if there is a paradox, then that means that there's a mistake somewhere, because paradoxes are not real things. You can't genuinely embody a paradox, right? But what is true is that there are things that are very counterintuitive. And so, I don't know. What's the most counterintuitive thing? Maybe the Andromeda paradox. And I made a video about this a while ago. Again, it's not a paradox because it's just, or I guess it's a paradox in that it's seemingly counterintuitive, or it's seemingly wrong despite not being wrong. The idea is that because what we consider now, like a moment of time, differs from person to person, depending on how fast they're moving relative to each other. So if I'm sitting outside at a cafe and somebody just comes walking by at walking speed, the amount that our nows differ by increases further away. So my now and your now will be the same right when you are like at the location where you're walking by me. But if we compared our nows 10 miles away, they'd be different ever so slightly. And the Andromeda galaxy is so far away that that our nows would be different by days. Now, this doesn't mean that the person who's walking by can see the light coming to them faster. Doesn't mean that they get to see into the future, because this has nothing to do with light travel time. This is just like what we call now the slice of our universe, the slice of our space-time that is now. That's the thing that differs. So that's a neat thing. It just means that what we consider now is not universal. And from Icy Spin with the $2, can a black hole absorb another black hole? Well, we call them mergers, but yeah, they can. What are your thoughts on nuclear? I like it generally. I think that you have to be really careful with it, but I like it generally. Do we know of any other planet that might have some sort of plants? No, we haven't found any life anywhere definitively. Are black holes spherical, or are they just infinitely flat? Black holes are, depending on their properties. They can be nearly spherical, or they could be perfectly spherical in principle. But most of the time they're going to be like a little bit like fat. But they're mostly, they're like little like fat spheres because they're spinning. How do you cook your bass? I don't. Could you talk about the recent discrepancies in the measurements of the gravitational constant g? Why is it so hard? Why is it so hard to get accurate measurements compared to other constants? That's on my to-do list of videos to make, so I'm not going to talk about it yet. But I will talk about it in a video soon. Have you seen Project Hail Mary? Yes, I have. What's your favorite part in relation to physics science? Well, most of it was like biology stuff, so it's not like the science was not the interesting thing. It was just a really good story. Sorry, I have to jump down to the bottom because I'm really behind. Why did my wife leave me? Well, from your picture, it's not clear that you had one because you look too young. But if you did, I'm sorry. They left you. How do you even detect a black hole spinning? Well, if a black hole is spinning, it changes the way it distorts light around it, for example. So you could in principle see that. What's your PhD in? It is in physics. Do gravity waves carry negative gravity on the downslope of the wave? No, they basically just they basically just go like this. They stretch, and I can show you a diagram. Or a GIF rather. This is a really good GIF. Why isn't it playing? Play, damn you. Why aren't the GIFs playing? Oh, there it is. Okay, let me show you the GIF. It's something like this. But like, notably, this doesn't cause like a gravitational attractive force. What it does is it'll like make stuff wiggle. From Icy Spin with the $2, what matter is a black hole made out of? We don't know. It might not even be made of matter in the traditional sense. But I appreciate the question. With time dilation and space contractions, what would you see if you traveled in a circle at the speed of light? Well, you can't travel at the speed of light, but you can travel close. The distance that you would cover would be seemingly small. Or rather, I mean, like, it depends, I guess, on what you're looking at and what direction you're looking into, which is annoying. But if, like, you were imagining that you were traveling along, like, a circle and you were only looking forward, and there were, like, markers, then it would look like that you're traveling over a smaller distance, that the circle that you're traveling over is shorter, or has a smaller circumference. Do gravity waves change the distance between 2 points? They do, yeah. What do you think about these scientists that keep going missing? I don't think anything of it. Most of them were not scientists. Most of them, they have no connection with each other. I think that there were only 4 scientists on the list, and over 5 years, yeah, some scientists are gonna die. Scientists are people too. Oh, that was my stomach. From Blancs with the $5, just had a friend mention the ice wall. What's your favorite way to debunk this? That you can just go to Antarctica. You can book a trip there. There's no ice wall. And then if they say, no, you can't, because the military, show them the international or the Arctic Treaty, and show them how in the Arctic Treaty it explicitly says no military allowed on Antarctica. From Brenda Creates with the $2, could strange matter collapse all ordinary matter? This was a hypothesis put forward by Witten and someone else, and I don't remember who. We don't have any evidence that this is true, but it hasn't been fully ruled out. And from Krenich with the $5, do you think that we'll find out what a singularity is made out of? I don't think that there are singularities. And as far as I know, actually, most physicists don't think that there are singularities either. Singularities are kind of just a placeholder for some unknown physics that we don't understand. And they show us, when they pop up in our math, they show us that the math, that we need new physics. What's the name of the YouTube channel that does Cavendish in a vacuum? I don't know if he did it in a vacuum, the guy who... but Steve Mould did it in a vacuum, I think. The guy who... The video that I've been showing is by... What's his name? By Blue Marble Science. You know if black holes are spherical? Most of them will be slightly oblong spheres. They will be slightly oblate even because they're spinning. Who's your favorite mathematical physicist? Probably Roger Penrose. How do gravity and quantum mechanics fit together? I don't know. If I knew, I would go get my Nobel Prize. Without a singularity, won't a black hole just be a gravistar? Not necessarily. No, I mean, there could be something else in the middle that we don't know about. BMS is a 2/3 museum quality replica. That's neat. How can it spin if it has no mass? Black holes have mass. From Fuzzy Kermit with the $2, best sci-fi and why is it The Expanse? I actually couldn't get through The Expanse. I found it so boring. Sorry. Do you know where a black hole leads? Probably to certain death. Do you think the Penrose process is viable for sapient races in the future? I mean, it seems viable, but it seems like it's unnecessary. You don't actually need to do anything particularly sophisticated to get to get a big chunk of energy out of a rotating black hole. There is a method that you can get more energy out of just by feeding the black hole and letting stuff swirl and then releasing light. From Chase Martin Physics with $5. Blitz, seriously, how do gravity and quantum mechanics go together? I need to know. Look, brother, I need to know too. Would it be possible to learn QFT without exposure to GR? Absolutely. Yeah, you don't need GR at all to learn QFT. Jump down to the bottom. Will I pass my Physics 2 course final if I watch your channel? No, you should do the homework. What do you think about the reports about faster than light travel using quantum superposition? I thought the probability of each particle being either spin was 0.5. How is transferring? It's not transferring information. I haven't seen these reports, but if somebody's claiming to have transferred information using like entanglement or something like that, then they're wrong. From the Satora tribe with the $5. If you travel in a large circle near the speed of light, your acceleration would be in 2 directions. Would it flatten in 2 spots? It's not about acceleration. It's about velocity, right? It's velocity that's relative, not acceleration. The length, contraction, time dilation, these are velocity dependent factors. I mean, acceleration will also play a role to an extent, but yeah, actually there was a thought experiment by, oh, who was it? Was it Ehrenfest? Let me pull it up. I think it was Ehrenfest. Yeah, it's called the Ehrenfest paradox. It's exactly this question, or very, very similar to it anyway. Sorry about that. From Ekipo with the €2, is dark matter thermodynamic? It seems to be cold, and it seems to not heat up. I mean, yes, it is thermodynamic in the sense that, like, you know, you could calculate the entropy for a dark matter if it's made of particles, for example, but it's not going to, it's non-interacting, so you're gonna have a hard time putting it in a box to get some sort of, you know, pressure or something like this, because, you know, kind of pressure requires a container. No, but they don't interact with each other, so there's not really any, like, any reason to think that there's really any pressure at all. They are what would be called pressureless. Pressureless dust, if that is indeed what they are. And from Tragan with the $5, how did our definitions of mass, distance, and energy coincidentally come out to exactly E = mc squared? Wouldn't there be some coefficient? No. The coefficient, well, okay, yes, the coefficient is c squared. Right, the c squared is the coefficient relating energy and mass. As a researcher, what efforts, if any, do you make to avoid motivated reasoning, scientism, and paradigm lock-in? Well, so I don't work with data. I don't collect data. Like, I'm not an experimentalist. I don't do observational astronomy. So I don't really have to worry about the kinds of bias that you would get when collecting data. Scientism isn't really a concern when you're doing science. Like, that's like a question for, like, philosophy of science, I guess. Paradigm lock-in is important, but, like, so the kind of physics that I do, when I'm doing physics, the kind of physics that I do is model building. And so that is very, very far removed from, you know, focusing on a particular paradigm. Like there's a model I'm working on now that kind of combines a few different features, a few different kind of, not fringe, but definitely theoretical ideas to try to see if some kind of phenomenon is, I'm being vague on purpose, by the way, to see if some kind of phenomenon is physically possible. And that's not really, that's kind of the opposite of paradigm lock-in. From Chris with the 50 Norwegian kroners, is Penrose's involvement in OR overblown, or does Penrose actually believe what Hemroth is proposing? Seems like a massive reach. I have no idea what Penrose personally believes, but yeah, I would imagine that his involvement is overblown. Okay, let me not say that. I don't know how much people think he's involved, but I don't think he's involved that much. Is college physics hard? It depends on the person. How do we know there were magnetic monopoles produced in the early universe if there are none now? We don't know that there were magnetic monopoles produced in the early universe. We just think that it seems reasonable that there would have been. You ever think about what do you mean by model? So a model is just a mathematical construct that then has some interpretation with physical reality. So when I'm building a model, what I do is I have some sort of physical idea, and then I try to kind of describe it mathematically to see if the mathematics can actually, using known physics, of course. You can make in some sense, you can make mathematics do whatever you want. But the trick is making the mathematics do what you want while following the laws of physics, right? And so I have this idea of this thing I want to see if I can make a model for. See if I can make like I have this like way that I think the universe could be. I'm not claiming that it is this way, but a way that perhaps the universe could be. So then I try to see, is it possible that the way that we understand the laws of physics is compatible with the universe actually being that way? From David Nikolai with the 12 euros, thank you so much. If information can't be destroyed in quantum mechanics, what actually happens to it when something falls into a black hole? And how does it come back out through Hawking radiation? Well, that's the million-dollar question, isn't it? Like, we don't know. It's generally believed that it does come back out through Hawking radiation, but it is not agreed upon how. And from Chase Martin Physics with the $5, college physics can be as hard or easy as your professor wants to make it. Anything in physics can be made difficult for students. Yeah, that's true. I also think that it's going to some extent, it's also going to depend on the preparedness of the student. If you have a student coming in the university who hasn't taken any calculus, then college physics is going to be much harder for them than somebody who has. The reality. And from Optopoppet with the $10, what are the names of the formulas used to derive the amount of dilation at percentages of C? Do they produce sound results at values higher than C? I don't know what a sound result is, but so what you're looking for is, I mean, the formulas don't really have names, but what you're looking for is relativistic time dilation and relativistic length contraction. And you can plug in values higher than C, and then you get imaginary numbers out. Do you believe that time is linear? If not, doesn't that mean that an action that exists always exists and always will exist? I don't necessarily believe that time is linear. I'm pretty agnostic about the topology of time. What's the youngest planet in our solar system? Blitz GPT. I don't know. Earth could be, because Earth kind of formed from like two protoplanets smashing into each other, but I don't know. Have you seen Oppenheimer? I have. What do you think of the scene where they need to show Einstein a calculation that showed the bomb could kill us all? Was it real? I don't know if it being shown to Einstein was real, but this was definitely something that people thought about. People were, you know, there was a concern that if you did this in the atmosphere, then the atmosphere would undergo nuclear fusion, or maybe nuclear fission. Anyway, they were concerned that it would ignite the atmosphere, but it was a very, very small concern. And, you know, it was resolved, and then they came to the conclusion that it wasn't actually a concern. Does the true randomness in quantum computing defy determinism? If not, could you briefly explain how? So in some sense it does, as long as you assume that there's only the one universe. Because then, yeah, then you do just get non-deterministic behavior. However, if we live in the many worlds of the many worlds interpretation of quantum mechanics, then the randomness in a quantum computer is just one outcome being realized, when in fact all outcomes are realized across the many worlds. So then there's no randomness at all, because all outcomes are realized. How do we transport antimatter? Carefully? I don't know the details. Have we ever measured speed of light in an actual vacuum? Depends on what you mean by an actual vacuum. But yeah, in reasonable senses, yeah. The death of identity. Okay, that doesn't seem like a physics question. What would you like to be your magnum opus? I don't know. Are there fundamental limits to how much you can reduce the Lorentz number using these approaches? Using what approaches? I'm missing something there. From the Satora tribe with the $5, which is much appreciated. Thank you. Everyone wanted to keep it simple for the class. You gave me something to read. Well, of course. Always happy to give more complicated explanations so that you can go find something to read. Is the differential geometry you learn in a math degree enough to understand general relativity? It'll take you most of the way. As long as you get to more than surfaces or more than curves and surfaces in 3 dimensions, then yeah, you should be fine. From Chase Martin, again, always good to see you here. Thank you so much. I find it unlikely the leading quantum mechanics minds of the time would bring a math calculation to Einstein at that time. He wasn't a fan of either. Yeah, I mean, I also don't think that I actually am not sure if he was a fan of the Manhattan Project either. But Oppenheimer and Einstein were friends. So it's possible that somebody would have. I just don't know if it's recorded. Can a rocket accelerating forever reach the speed of light? Nope. It will get there. It will never get to the speed of light. It'll just get arbitrarily close. Who's the best science communicator? Neil deGrasse Tyson, Brian Greene, and Brian Cox. I don't think any of them are the best science communicator. I think that the best probably is Matt O'Dowd. Well, okay. Maybe not Matt O'Dowd. He's definitely one of the best. What's your opinion on modified Newtonian dynamics as an alternative to dark matter? Look, if they can make modified Newtonian dynamics account for the bullet cluster and make it covariant and make it variational, then I might sign on. But until then, I'm a little bit skeptical. Yeah, Matt O'Dowd is PBS spacetime. Why did Einstein hate quantum physics so much? I don't know if he hated it. I just think that he didn't like how it was being interpreted. What do you think of Sean Carroll's books? I haven't read all of them, but the ones I have read are quite good. Do you believe Bob Lazar's story? No, not in the slightest. What do you think about portable antimatter in terms of generally getting FTL technology? Portable antimatter is really, really hard to have exist. Like, it's really hard to transport antimatter, and it's really hard to make antimatter, and neither of those will help you get to faster than light speeds. Thoughts on Hank Green as a science communicator? He's really good. He's a generalist, though. He's not a specialist. From Chase Martin Physics, again with the $2, this is true. MOND is harder to get behind the new particles. Yeah, look, there are probably particles that we haven't detected yet, and so it's plausible that some of those particles are dark matter. Why do you need to completely invent new physics when you can just invent new particles? Not to say that it's necessarily right that it will be new particles this time and it won't be new physics, but like, I don't know. I'm skeptical. Don Lincoln from Fermilab is also good. He's just not very out there, right? What do you think about Jack Parsons? Why do I know that name? No idea who that is. Let's make sure that I didn't miss anything. We're good. We are good. Was there anything to the paper indicating dark energy? Maybe WIMPs? No, not dark energy. Dark energy is not WIMPs. Is Neil deGrasse overrated? I don't know if he's overrated. He just has a different vibe. He's definitely appealing to like the broadest audience he can. Would you have watched a physicist TikTok live if it were available when you were growing up? Probably, yeah. What are your thoughts on microscopic black holes for a theory of dark matter? I actually quite like it. But the evidence for it keeps getting, or the possibility space for that to be the answer keeps getting smaller and smaller. Thoughts on Kyle Hill as a science communicator? Well, I used to like him a lot, and then he ghosted me and a friend attempting to hook him in for a game of Magic the Gathering. No, like, no hard feelings. He seems busy. But yeah, he's quite good. I haven't watched his stuff in a while, but I used to watch it a lot. Antov Petrov is a good one. Antov Petrov is perhaps after my time. I just don't really watch a lot of YouTube anymore. So I don't know how long he's been doing his stuff, but I never watched his stuff when I was watching more YouTube. Why is virtual particles popping in and out of existence accepted lore? I don't know why it's accepted lore, but it's not real. Do you think bio AI will boom? I have no idea what that is. Oh. Oh. Well, thanks, Raymond. I appreciate that. I didn't know that that was your username. Okay, I'm not going to dox you, of course. All right, last one from Chase Martin because he's poor. Wouldn't microscopic black holes radiate away too quickly to be as long-lived as we suspect dark matter to be, and not my field? Well, okay, yes, probably not microscopic. They have to have a massive, like a small asteroid, in order to not have evaporated away yet. And so you could work out how big they are. Just type in a Schwarzschild radius calculator. No, we want a Hawking evaporation calculator, and we can just punch in and we can just work out what the required size is, what the minimum size is for that. So if we say that we have, I don't know, we need a lifetime in around 13 billion years at least. So if we do like 10,000 kilograms, that gets us, nope, we need maybe 100,000. Why don't we do metric tons? 1,000 tons, nope. We need maybe 10,000 tons. 100,000 tons. Wait a minute. 1 billion tons. Okay, 1 billion tons would last long enough. Would last the age of the universe, no problem. Even 100 million tons would. And so a black hole that has the mass of 100 million tons is, you know, this is, yeah, this is it's 1/10 millionth of a nanometer. It's you know, 0.14 femtometers, something like that. So that's definitely microscopic, and it would still last long enough. From William Murphy with the $5. Hi Blitz, I just got my PhD in Mech E. Well, congrats. Am I a scientist or an engineer or a secret third thing? Probably an engineer. I guess it depends on what you do. There's definitely overlap between the two. Are you doing engineering or are you doing science? So perhaps a good way to divide the two. And look, I'm not the final arbiter here, but the way I see it is an engineer is trying to solve problems. A scientist is trying to answer questions. Like why or how does XY, how does high temperature superconductivity work? Or why do black holes glow a certain way? Or what is the most, you know, what is the, I don't know, you know, answers questions. That's my view anyway. Are you a physicalist? Kind of. Probably the closest thing to my view. What do you believe is the best undergrad physics course in the world? Do you believe it is Cambridge, Nazi, Tripod, or another course? I don't know. I don't have, yeah, I just don't know. Can't evaluate them. I've only ever done one. Saying the only true science when he admitted to having no education in physics and thought it had nothing to do with the shape of the Earth. Oh, yeah, that wasn't for me. You still have cancer? No, it turns out it was never cancer to begin with. Most mad scientists are actually mad engineers. Yeah, that does happen. Dalton Raid. Hi, Dalton. You look like Dean. That's crazy. That's a crazy claim. I don't, well, and not to say that, not this, yeah, he's blonde, he's like, we have like different face shapes. Is that a cut? It's a scar. Not a nose, it's not a nose ring, it's a scar. I wish I didn't have it. I bumped my question because I don't think it was addressed. What theoretical observational developments do you think are needed to resolve Hubble tension? Well, look, so the Hubble tension is pointing at one of two things. Either the way that we measure distances is wrong, or our cosmological models are wrong. And so either one of those would resolve it. If we found a source of systematic error that we had not noticed before in our measurements of distances, that could resolve the Hubble tension. Or if we find evidence for new physics that pushes us into thinking that the lambda CDM model is sufficiently wrong that the Hubble constant we get from it is incorrect. Are scientists looking into the theory that black holes have phases of age, the age of the black hole dictating its internal stability and thus its destructive nature? No, because this doesn't seem like a scientific idea. How old were you when you finished studying? I was 29. Or I guess I was about to turn, yeah, I was about to turn 29. Oh, Supernatural Dean. That Supernatural Dean. You mean Dean from the show Supernatural? Okay. Was she stuck? Where? She's so dumb. Sometimes she stops. Sometimes the brain cells are on rent. Why would she lock herself in the bathroom and then complain about being in there? Layaway, there you go. Somebody's renting her brain cells because they're on layaway. The real cancer is the friends we made along the way. I had a benign tumor removed back. So it turns out it wasn't even a tumor, much to the surprise of my oncologists. I have a cat. Well, yeah, I mean, people always want to see. All right, my wife's gonna go get the cat so that you guys can meet. I mean, some of you have seen her. Show the cat. Here's the cat. He's very upsetty spaghetti. Meow for the camera. Okay, you can leave. You may leave. Yeah, so it wasn't even a tumor. From Time with the $5, for the Raiders' knowledge, Blitz has not caught a bass, and email 1776 is a liar. Hold on, let's not disparage chatters. I don't know who email is, so. Should have named her Cloud? No. But she was very, very cute when she was a kitten. Like, so cute. She is sweet, but she's also, like, kind of mean sometimes. All right, let's drink some water. I'm a little bit dehydrated. Oh, email is Ty Wolf on a crusty sock account. Gross. Did you just misgender that cat? I did. You ever been to CERN? I haven't. I probably could have, but you know, going to Switzerland is not cheap. What do you think about the possible proof of microscopic life on Mars? I think that we have evidence. I don't know if we have like smoking gun proof yet, but I think that we have pretty good evidence. You look like a younger version of Geddy Lee, Russia's bass guitarist. This is a major compliment. I know who Geddy Lee is. People compare me to him a lot. And by a lot, I mean like more frequently than they compare me to basically anybody else, but that's not saying much. Is the cat aware she's owned by a physicist, increasing her understanding of the universe? No, she is aware that she is owned by, or rather that she is living in the abode of a giant hairless cat that provides her with crunchy food twice a day and also gives her inhaler. That's what she knows. She doesn't know anything else. Do you do IRL streams? What's an IRL stream? Oh, no. You think I touch grass? Is the cat aware a stranger, loves her? She is not. But I'll try to let her know. DCC theory, please. It's not a particularly mainstream view. I haven't looked into it in too much detail. I mean, I'm familiar with the idea. I haven't looked into the evidence for it too much. My understanding is that there's just not very compelling reasons to... The data is not particularly compelling, is my understanding. A stream where you're doing physics work would be neat. Well, look, the thing is I could do that. I work from home. But that risks showing my stuff, the stuff that I'm working on that is unpublished, and the stuff that, you know, you try to keep close to your chest because you don't want it getting out into the world so somebody takes your idea. That would mean live streaming that stuff. Which, you know, not to say that the odds are great, but it would really suck to have somebody else who just happened to be scrolling on YouTube get my idea and then, you know, write it first. Can space be undefined where there's no matter? Well, I still don't think it's undefined. How do you find FLERFS to debate? Well, today we struggled to find any because, I mean, maybe they're all gone. If a food bowl is 75% full, is it still 100% empty? Yes. Ask a physicist, but accepting guests would rock my world. I do accept guests. I used to do it a lot. Now and then I stopped for a while, and I'm starting again. That's going to be on Wednesdays, but not this Wednesday because I'm going to a friend's thesis defense instead. So the live stream, there will be no live stream on Wednesday. What is physics work? Is it research? Yeah. What is paid science, private industry science? Oh, that wasn't for me. I thought you were a psychiatrist at first and I was going to tell you all my problems. Oh, no, I'm not. Please don't tell me your problems. Would you debate Witsit Gets It? I've debated him before. You can go find a video of me debating him in a 3v3 on YouTube. It was on Jeranism's channel. Just look up Blitz PhD or look up Dr. Blitz and Witsit Jeranism on YouTube and you'll find it. A re-ask because it got buried by cat posting. Ever check out the Foundation series? I haven't. Actually, I started it and I was very, very bored. Witsit destroyed me? You think so? They never addressed any of the scientific claims that I made. How are you feeling after going through a surgery? Well, now I'm feeling mostly fine. I still have some leftover issues, but those are hopefully going to be resolved. From William Murphy with the $5. Have you heard of cold plasma? Our lab works on cold plasma plus biointeractions. Our tech was FDA approved for cancer. Very cool pictures. I haven't heard of it, but that seems neat. Would you ever work abroad again? Probably not, unless my wife was okay with it. It was just hard. It was hard on her because it was pretty isolating, and while I had kind of a built-in social circle, both from this, like the online stuff, and also where I worked, she didn't. And there's a big language barrier, so it was really, really isolating for her. And, you know, I'm not going to ask her to do that for me again. Now, if she runs off with Jeff Bezos, then, you know, maybe. But I don't think she'll do that. Sorry. Want to start with Star Trek? Which Star Trek series should I begin with? I'd like to say begin with Star Trek The Next Generation. Very good. The first season is a bit rough. So you could probably skip the first season. What topology do you have to use, if any, in your research? Very, very minimal. Like, very, very minimal. Like, Euler characteristic is basically all that ever shows up. Yeah, skip Code of Honor. Bad episode. Straight up bad. Thoughts on beardless Riker? It's awkward. Can you explain why most physicists don't accept singularity? Well, look, I haven't taken a poll. This is just my my feeling for, you know, based off the people I've spoken with. But when a singularity happens, at least when it's happened in the past, when it shows up in your math, that implies that your math is wrong. It doesn't imply that there's actually some measurable infinity somewhere. And so, like, yeah, we know our math is wrong. Why would we trust the math when we know the math? When we're talking about the math, I mean, like, the physics. The physics breaks down at, like, the center of a black hole. The physics breaks down 13.8 billion years ago. We know that it's wrong. Why would we accept the conclusions of something that we know is wrong there? Do you think theories beyond the standard model will be proven by observing top quark flavor-changing neutral current decays? If we're seeing FCNCs, is this like a recent thing? Was this detected? I mean, like, yeah, generally. Okay, so it wasn't detected. Yeah, generally FCNCs are really, 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 really rare. So probably, yeah, they would be. It would be evidence of beyond the standard model physics. But I don't think this has been seen. Thoughts on bearded Wesley? From Wayne Cottrell with the 10 pounds. It's very much appreciated. I see they've made great strides in ion thrusters for rockets. However, they will move very slowly. Do you think they'll be able to allow faster speed than we have now? And is it the way forward? The thing about ion thrusters is that they're extremely efficient, meaning that you have to carry very little fuel for a given amount of change in speed. The downside is that they are very, very low thrust. So, like, for deep space missions, ion thrusters are perfectly fine. But for, like, moving any substantial, for, like, moving people, like, no. Unless your ion thrusters are, like, way more powerful, which, you know, they're not. It would just take too long and you'd be wasting people's lives accelerating. Saw something recently that they might be able to split quarks. Is that legit? Can they be broken down into something smaller, or am I stupid? Well, I don't know if you're stupid. I don't know what you saw, but as far as we can tell, quarks are the fundamental particles, meaning that you can't break them down into something smaller. What are your thoughts on Neil deGrasse Tyson? Do you find him annoying when he constantly interrupts? I don't really have strong thoughts. I think he does a good job bringing people, bringing interest from the public to science. I think that that's a good thing, but I don't have otherwise strong feelings about him. Is the universe inside of a black hole? I don't think so. I think we have good reason to think not. But a black hole can rip them? It can't rip quarks apart. At least not as far as we can tell. Maybe. Maybe we'll find out that they're not fundamental someday, but we don't have any evidence that supports that right now. I like the black holes creating universes thing. No clue about the science, but it's interesting for sci-fi. It is interesting for sci-fi, but it's not really well supported by the data that we have now. Next stage of research on black holes. I don't know what you mean by next stage. Why does the expansion look like it's moving away from us? Well, look. Imagine that you are a dot on a balloon, right? And there's a whole bunch of other dots. You're one of the dots. If you start blowing up the balloon, it will look like, from your dot's perspective, that all of the other dots are moving away from you. But that'll be true for any dot. And it's because expansion is happening everywhere. So it's going to look like everything else is moving away. What do you think? Oh, that's not a question for me. Oh, do you think the ability to have manned deep space travel... Do you think the ability to have manned deep space travel will ever be possible? There's a lot of biological and medical problems that need to be solved first. Or we can just build a generation ship where we just put like 5,000 people on a hollowed out meteor and then send them on their way. Is there a next step or a plan to learn more about them in any way? I mean, like, this science isn't done by like by like everybody comes together and decides on what to do. You just have a whole bunch of scientists that are doing separate things. So like every scientist that's interested in studying black holes is going to be having some, you know, whatever they're doing next in their research trajectory is going to be whatever the next step is. How is Andromeda on a collision course with the Milky Way if expanding is making everything move away? Expansion doesn't make everything move away. It only makes the things that are not gravitationally bound together move away. So Andromeda is gravitationally bound to the Milky Way, or rather the Milky Way is gravitationally bound to Andromeda. And so those two things will not be forced away from each other. Time starts with the Big Bang. How possible is it that Big Bang happened without time? Well, it's not clear that time did start with the Big Bang. But if it did start with the Big Bang, then I guess you would have some sort of pre-geometric or pre-temporal geometry. Could be an explanation for how time started. Follow up, what shape is the universe? As far as we can tell, it's like a three-dimensional grid, and it doesn't have any intrinsic curvature. How realistic is the new power source in our lifetime? I think it's pretty realistic. Well, I don't know how old you are. Would you rather be the first to discover the start of a new field of science that changes civilization forever, or be the last scientist to discover the last truth of the universe? I'd rather be the former. How are gluons discovered? I mean, particle accelerators, basically. What is that beeping? That's not the, What's the best way to start intuiting math alongside practicing? That is the best way. Hydrate. Okay, I will hydrate. What are your thoughts on Babylon 5? I've never watched it. I'm gonna jump down to the bottom. What are your thoughts on the fast 16 worm? I have no idea what it is. Check your carbon monoxide detector when you hear a strange beeping. I know what the beeping is. It's a wine cooler. And the unfortunate thing is that it seems to be like glitching. And so I need to shut off all of the breakers. And the way to fix it is to shut off all of the breakers and then leave them off for a minute and then turn it back on. And that's just annoying because, well, I have to shut off the breaker, but I don't know which breaker it goes to the wine cooler. And so I will have to probably shut off everything. And so I can't do that until everybody is okay with me doing that. So geometry doesn't need to be consistent at all scales, despite what Euclidean model says. Imagine a locally Euclidean, globally preferential planar manifold with curvature suppression effects that's flat. That's roughly right. Can't you just unplug it? To unplug it would mean it's like it's like built in and it's not on wheels. And because I had surgery, I'm not allowed to lift or move heavy things. So, and I'm probably the only one who can do it. So I just need to shut off the breaker. Yeah, it's annoying. How does your knowledge of electromagnetism translate to being an electrician? Could you be one? No, they're different fields, or not fields, they're different skill sets, right? Like in principle, I could probably learn enough to like, you know, give me 6 months. I could probably do like a half decent impression of an electrical engineer, but not an electrician. An electrician has a lot of practical skills that I just don't know. Label your breakers. Don't tell me what to do. Get ready to reset the stove clock. That's what I'm dreading, basically. It's just annoying. Can you please explain how light travels through the vacuum of space? Light has no time. Is it invisible while it's moving until it hits something? So light is a wave. It's a wave in the electromagnetic field. The electromagnetic field exists everywhere. So that's how it moves. The electromagnetic field is everywhere, even in a vacuum. And it's just a wave in that field. Now, the statement that light has no time is a misconstrual of a misconstrual of a misconstrual. Light doesn't have a valid reference frame. So it's a meaningless question to ask how much time a light beam experiences. Not that it's zero, just it's meaningless. And when we say that light is invisible until it hits something, the point is that what it means for something to be visible is that light has entered your eyeballs from that thing. So light itself doesn't give off more light in the sideways directions, right? So, unless it's like bouncing off of stuff. So yeah, it will be invisible until it hits your eyes. Can you briefly explain the Koita formula and its impact on particle physics? I can, but I did do an in-depth video on it. If you just look up Blitz, if you look at my name on TikTok and then Koita formula, you will find it. Briefly, it didn't really have any impact on particle physics because it seems like it's a numerical coincidence, but maybe it's not, and we just haven't figured out how it's not yet. Is the guest waiting room on Discord not the right place for this kind of segment? I'm not taking guests right now. How does the size of a surface determine what frequency of an acoustic wave is reflected? Well, if the wave is bigger than the features on the surface, then it's not going to interact in the way that typically geometric optics would, which is like the kind of reflections that we like. So if maybe that answers your question, but that said, high frequency sound waves have short wavelengths, so they can interact and bounce off of in like kind of optical ways, geometric ways, off of smaller surface features. Do you have any unusual niche interests like watches or pocket knives? Not those. Magic the Gathering isn't particularly niche either, so I guess no. Are the fundamental forces equally fundamental? Perhaps. We don't know. Does your knowledge of physics influence how you think about everyday experiences? Different to most people? Well, I don't know how most people think about things, so are micro black holes a real thing? If not, why not? And if so, how? Well, we've never detected them, but they're like physically possible. What are your thoughts on being able to move from one place to another based on vibrations? That's fantasy. How has quantum mechanics been so useful yet so many people say that nobody understands quantum mechanics? The people who say that nobody understands it just are wrong. Like, so many people understand it. I remember you saying that you took a topology course that was difficult. What exactly made the course difficult, that other than math courses? I was what you might call mathematically immature. So I was a freshman, right? I hadn't taken any like serious math classes. I hadn't even taken, or I think I was taking a proof class concurrently with this one. And so it was just a mistake. Like, I just wasn't ready for it. I wasn't ready for the level of mathematical sophistication that you encounter when you take a topology class. What's your favorite kind of food? I like East Asian and Southern. I don't know. I like pasta a lot. I like things that are heavy in carbs. Like, I love carbs. But I also really, really like Indian food, generally. You play Commander, who do you main? Okay, one sec. That's the guy. And here's the deck. Oh, that's hilarious. It's green, so you can't see it. It's like the same color as my green screen. I shouldn't say I main it because I don't play it often because it's very stompy, and it's a CEDH deck, so like I can't play it unless it's against other CEDH decks. But when I do play CEDH, that's what I play. Otherwise, I have a whole bunch of decks that I play in more casual settings. Did you ever test your IQ? I think it did happen when I was a kid, but my mom never told me the score, which is probably a good idea. Did he answer the egg question? What egg question? Thoughts on us going back to the moon? I mean, it's neat. It's not really science, but it's neat. Do you happen to play on stream? No. If, like, look, if some channel, if some YouTube channel, Jimothy, ever invited me to come be on their show, I would absolutely be happy to do that. But nobody has, so. From Nick N with the 5 Canuck bucks, what are your thoughts on the cube food rule? Are hot dogs a type of taco? Hot dogs are a kind of taco, or perhaps tacos are a kind of hot dog. I haven't decided. But yeah, I mean, like, that seems right. Most people don't know why things actually fall. You understand it's a consequence of geometry, but most just think it's like it's an invisible force like magnetism. Well, that's true. That's definitely true. If we're in a series of simulations, what would be the religion of the host simulation? I don't think that, well, I don't know. I don't think that we're in a series of simulations, though. The United States has 3 different time zones. Doesn't it have 4? No, it has 4. What are you talking about? Oh, God, that beeping is so annoying. I need to fix it after the stream. TCGs were the first pay-to-win games. They absolutely were. A lot of people are very, very happy with, or fine with proxies these days, but sometimes you want to get the actual cards. So for this deck, I did. But you know, for most of my other decks, or for many of my other decks, they're very proxy heavy. Did you ever get into any other TCGs? No. Currently studying, okay. Currently studying for my Physics 2 final. I take it in 4 hours, need a 70 to get an A in the class. Any tips? Go study, don't watch me. Where can I support you if TikTok is banned in my country? I do a lot of the stuff that I do on TikTok on YouTube as well. Hot dogs refer to the filling, and they're both paninis. A hot dog's not a panini. Not pressed. Can we do new science on the moon, though? Geology and stuff with low gravity? Yeah, we can, but that's not why we're going back to the moon. Well, yeah, the continental US has 4 time zones. Is gravity not just magnetism? It is not magnetism, no. All right, y'all, it is past noon. I am hungry. My stomach's been rumbling all morning. So I'm going to end the live stream here. I will see you guys again tomorrow for more Ask a Physicist and perhaps some Kerbal Space Program as well. Make sure to join the Discord server if you haven't already. It's pretty easy to get to if you want to get updates on when I'm going live. It's discord.gg/drblitz. Just Dr. Blitz, discord.gg/Dr. Blitz. Very easy to find. And if you want to check up on the research that I'm doing, if you want to look at the science communication, the other science communication stuff I do, feel free to go to my website. It's blitz.phd. That's it. There's no .com. It's just blitz.phd. And if you do want to support me, at the bottom of all of the pages on the website, there's a little like taskbar where you can like see support, figure out how to support me, and then there's links. So I will see you guys tomorrow.